Thank you all the attendees for joining us today. I hope all the attendees had a great time networking with your peers in our exhibition tables. In case you haven't, no worries. You will still have time as the platform will be open till 6 p.m. today, so you can start networking. Now, can I request my team to start playing the sponsor videos?
Decades, we experienced the rise of Chinese photovoltaic companies and the transformation of Longi from a pathfinder and an inventor of technology to an industry leader. Longi was established in 2000 and changed the game rules of the industry by promoting monocrystalline modules in 2015. In 2016, Longi's mono-PERC technology brought the industry into an era of high efficiency and low LID. In 2017, Longi's bifacial PERC technology increases remarkable module power output with rare side irradiation. In 2019, M6 silicon wafers led the PV industry to an era of 450-watt ultra-high power. With strong innovations, Longi has made numerous achievements like 24.06% efficiency of monocrystalline PERC cell, the highest production of bifacial monocrystalline modules in the world, continuous technology advances and LCOE optimization. Now, Longi is about to set off another advancement in the industry once again. The latest Longi high Mo5 modules with optimized LCOE, especially designed for large-scale PV stations, are now available. The power output of high Mo5 is up to 540 watts, with over 21% efficiency. The optimal size of the high Mo5 module, coupled with sophisticated construction, can reduce costs while increasing power generation. As seen in the PV station in Zhouchuan, China, high Mo5 can significantly lower labor, land, and BOS costs and reduce LCOE. Also, the application of high Mo5 in Qatar has proved to be a remarkable improvement in cost reduction. The advanced technology of the high Mo5 leads to optimal LCOE, which is the result of Longi's exploration of every detail of functionality. New M10 gallium-doped silicon wafer can reduce the linear power degradation to 0.45% per year. Compared with the traditional welding technology, Longi's smart soldering technology reduces the tensile strength of the cell by 20%, by reducing the distance between cells by 2/3. This technology achieved a 0.3% improvement in module efficiency. High Mo5 follows a mature and reliable design path, framed, tempered glass on both sides to ensure the load capacity of the modules, with no crossbeam on the back to the module that blocks reflected light to ensure continuous and efficient power output. In practical applications, the size of high Mo5 is suitable for the main 1-portrait and 2-portrait horizontal single-axis tracking system. At the same time, it is perfectly compatible with the next-generation inverters. The working current, including 15% bifacial gain, is kept within 15 amps, without the loss of current generation. Standardization, perfect adaptation, cost optimization, and high efficiency leads to optimized LCOE that enables high Mo5 to be one of the most valuable products on the market. The high volume production of high Mo5 is ready. By first quarter of 2021, global supply is expected to reach 13.5 gigawatts. The new high Mo5 joins the Longi high Mo family, bringing in a new PV era with ultra-high value.
the energy demand of the world is always full of challenges. Therefore, we need more advanced technologies and solutions to integrate and solve all those problems. In the field of green energy, TBEA provides optimal solutions for smart photovoltaic power generation, voltage and reactive power stability of the new energy power station, smart microgrid, as well as lean operation and maintenance. Value comes from technological advancement. With the advent of the era of photovoltaic parity, the value brought by technological innovation has become more and more important. As one of the earliest companies engaged in the inverter R&D in China. In the field of string inverters, TBEA has introduced the optimal cost system solution with a new generation of high-power inverters as the core, increasing the comprehensive income of photovoltaic power plants by over 7%. In the field of central inverters, TBEA 1500 volts 5 megawatts outdoor central photovoltaic solutions use advanced parallel design and flexible matching to increase the comprehensive income of photovoltaic power plants by over 3%. Value comes from reliable operation. TBEA provides grid-side voltage safety and stability solutions for new energy power plants with a cumulative application performance of SVG exceeding 5 GVAR. For SVG, the PCBA is sealed with silica gel to meet the complex environment such as dust, condensation, salt spray, etc. The product also applies IGBT temperature real-time monitoring, water and electricity separation, and other technologies, has passed a high and low voltage ride-through test, so as to provide reliable protection for grid-side voltage and reactive power safety. Value comes from intelligence and efficiency, led by self-developed, high-end power router, supported by key products such as Energy Management System, EMS, Central Controller, Energy Storage System, etc. TBEA put forward customized 1-core 2-drives X-Scenes smart microgrid solutions for industrial and commercial parks, data centers, islands, and areas without electricity. Value comes from lean operation and maintenance. With support of technologies like big data, cloud computing, AI, etc., TBEA built the TBE Cloud Smart Energy Management Platform. Through overall real-time collection, transmission, calculation, and smart processing of massive data produced by power stations, station monitoring, production management, operation and maintenance management, and investment analysis can become simple and convenient, which can increase power yield by over 3% and achieve lean operation. Dedicating green energy to create a better life. TBEA focuses on smart photovoltaic power generation, high-efficiency power quality management, and smart microgrid technology innovation, and is determined to become a global smart green energy service provider.
APAR is a leading brand of electrical and telecommunication cables. Two modern manufacturing plants in Western India have fully integrated facilities to produce a wide range of high technology cables, ranging from high tension and low tension power cables to elastomeric cables, telecommunication cables, including fiber optic cables. Advanced CCV technology system for manufacturing high tension, high voltage cables. Fully integrated manufacturing of elastomeric cables for special applications like windmill and solar power. First of its kind, electron beam irradiating curing facility for cables and a variety of other products. High technology systems for precision manufacture of fiber optic cables. The production lines are integrated with stringent quality management processes, testing the cables to withstand hostile conditions like fire and smoke while ensuring durability. Today, cables from APAR are used by leading power utilities, nuclear power plants, refineries and petrochemical plants, steel plants, shipping, defense, telecom, and the railways.
Can't hear you. Your audio is not coming.
Twinkle, we can't hear you.
You are on mute, Twinkle.
No, we can't hear you.
Twinkle, you are on mute.
There is some connectivity issue from Twinkle's side. So, on behalf of her, I am welcoming everyone to this virtual conference. So, let me take you through the agenda for the day. We will be having two presentations followed by two panel discussion and Q&A for each panel discussion. The first session will be focused on engineering innovations, understanding the latest technology trends, and the second will be focused on rehybridization, engineering aspects of solar plus storage, BESS. Now, without any further delay, let us begin with our first sponsor presentation by Mr. VK Bajaj from Apar Industries. Welcoming you on the screen, sir.
Thank you very much, Priyanshi, and my best wishes to all the audience members and other panelists who have joined in today. And it is a good honor to me to be presenting this to you.
Thank you so much, sir. You can proceed with your presentation.
Is it visible?
Yes, sir. We can see it.
Thank you. You are already, we are doing a lot of almost all the solar projects and windmill projects. We have been a very leading presence in these segments, and therefore may not be a new name, at least in the Indian context. So I thought, let me present to you some of the products which we have. We have a very wide range of product. So first of all, let's a little bit on the APAR. We are a 8,000 crore company with three verticals: specialty oils, conductors, and cables. I am talking on behalf of the cable division, where we manufacture various type of and very wide range of cables. We have two manufacturing facilities, both located about 150 kilometers from Mumbai. in just bordering Maharashtra and Gujarat in Umargaon and Khatalwada. This is before Vapi, if many of the people may be knowing. So company has been manufacturing since 1981 and a very, very vast infrastructure of about 200,000 square meter. And the facilities at Umargaon, as I mentioned, all the facilities are certified under ISO systems. And we have also in-house NABL accredited testing laboratory. And in terms of our annual production is about 30,000 metric ton of aluminum cable and 10,000 metric ton of copper cable. Broadly, the cable is also divided into three verticals. One is the electrical cable, other is the elastomer electron beam cable, and third is the telecommunication cable. And all these products are also used in the solar segment. Electrical cables, we make up to 1000 square mm, 66 kV, and various type of cables. Then in elastomer side, we are a leading player in the windmill and the solar cable segment. And also we supply optical fiber cable for some of the SCADA system. So solar cable, we are amongst the largest producer of cables for renewable segment. And we have three electron beam facilities. One is 1.5 MeV, 2.5 MeV, and third one is the 3 MeV, million electron volt. And this is used for cross-linking of elastomeric insulation and sheath material for various products, including solar DC cable. In terms of range of cable, we have right from 2.5 square mm to 300 square mm cables with electron beam cross-linking. Duly certifications are available as per BSEN, TUV, IEC, as well as UL 4703. In fact, besides the domestic Indian market, we have a very large presence for UL 4703 PV photovoltaic cable to USA. The solar PV cables we can offer with rodent resistant feature. This rodent resistance also, I think, is covered in the later part, can be in by different methods. Then we also have developed flexible aluminum conductor solar AC and DC cables. So this is a new, because the cost of copper has gone up so high, almost double in the last 1 year, polymer prices have gone up. So we thought to develop this flexible aluminum solar cable. So if any of the participants are interested to do some experimentation or testing, etc., we have done our in-house testing, but maybe it has not been tried in the field. So if somebody wants to interact with us, we'll be happy to support. Then we have aluminum XLP cables with steel tape, flat strip, round wire armoring, which is generally used from combiner box to inverter and onward. And we have medium voltage cable also going to the grid. Then we have nylon jacketed cables as per Australia and New Zealand specification for rodent protection. I think it has not caught up in the Indian side because I think they have not faced the O&M problems as vigorously as they have faced in Australia. So I am sure very soon the people who have O&M pains will definitely look at this option. Then we also can offer electron beam irradiated LT XLP cables, which are suitable up to 120 degrees C operating temperature. And these cables can offer 15% extra current rating over conventional cables. Of course, you have to consider the voltage drop and other aspects. But the cables can give you far more life than what is normally available from the conventional cable. Then we have RS485 and fiber optic cable for SCADA. Little bit on the electron beam technology. We are the only site in India with 3 electron beams, and we do it for various cables and other products. The basic technology is the very old cathode ray system which we used to have some 30-40 years ago. The TV, which used to be very bulky kind of thing. An electron gun is housed in the very thick vessel, where electrons are accelerated and in an acceleration tube, and they are directed to a scanning device which is magnetically scanning over the material. So the benefits are far better, superior cross-linking of polymer and improved thermal and mechanical properties. This is just a glimpse of the electron beam facility. Many of our solar segment customers have visited our facility, and we are happy to show them too. Some critical challenges which the DC solar cable system has to sustain. One is that definitely from the bankability purpose, the expectancy of 25 to 30 years is required, which is very much possible by only by electron beam cross linking. So therefore, 90% of the production worldwide for solar cable is done by electron beam, although some people do it by Cyaplas moisture cure method as well. So here the electron beam cross-linking is done by bombardment of electrons, which I explained, accelerated electrons onto polymer and at very high acceleration penetrating between the weak covalent bonds and thereby cross-linking adjoining carbon bonds. This is a technology, I think vulcanization and cross-linking, there are many people who understand it very well. Flame retardant and other UV property, etc., is by compound formulation. Anti-rodent and anti-termite can be by chemical additives or mechanical protection or both. And these cables which we sell are RoHS compliant. The issue which is faced primarily in the O&M side is the rodents, in particular rodent, squirrel, termites. These cables get, these rodents have habit of, chewing it or gnawing it on anything, whether they like it or not. And invariably, if they like the taste, then they chew it up and then damage the wire. Except hard surfaces like rocks or metals, hardly any surface can escape the sharp bite of rodent, and depending on the specific type and the location. So it is not necessary that you have used a chemically additive rodent protection material and it becomes anti-rodent. It cannot be, because it is like mosquitoes. If you use good night or you use something else, you have to keep changing it, because they develop a habit of uh, the smell of that chemical additive, and then over a period of time they do their own engineering and then develop new methods of achieving it. Similarly, termites, I think not so much problem in India, but maybe in Australia and Vietnam, this is a big problem to my understanding. So there are method of protection. One is, as I mentioned, you can add chemical additive. Here, point number 3 is there. Chemical repellent additives can be added into the compounding, into the sheathing material. They deter rodents with unappealing taste, less effective in the long run as the chemical evaporates after some time, and besides, the rodents get used to the taste. So this is the problem with the chemical additive. This is a very low cost option, but you cannot expect rodent resistance by this method for 25 years, maybe 2 years, 3 years, till the smell lasts. So there are other methods like mechanical. You can do mechanical metallic armoring, which can be corrugated steel tape or steel braiding, but most effective, but certainly a little bit compromise on the flexibility, cost is higher, and the steel will need earthing of the armoring. Other mechanical can be non-metallic glass yarn covering between the insulation and sheath. This is very effective, but compromise on the flexibility plus high cost. Then I jump to nylon polyamide 12 intermediate sheath. It is very effective for rodent and termite, retains flexibility, very popular in Australia. And it is the nylon 12 is a very tough material. It resists all the rodents and termites. This sheath is provided between insulation and outer jacket. And therefore, it also improves the electrical properties as well. Then you can have two options. One is the nylon 12 you add in the intermediate sheath, plus also add chemical additive in the outer sheath. This is the best ideal solution. The cost may go up on this side. So these are the various methods of rodent protection which are available. The effectiveness is also mentioned in that. Then we are also recently, about a year and a half ago, we entered into the wiring harness business. Presently, we are doing some work on the harness for automotive and EV, harness for locomotives, railway coaches, and this harness for solar projects. So we have executed some 2, 3 large projects where 100,000 connectors were involved. So this is another area which maybe we can offer to the Indian industry, because this practice is very predominant in all the overseas markets where perhaps the labor cost is much higher. But here, if you have the harness, then the cost can be lower. So APAR uses its own solar DC cable for these wiring harness. We have significant experience in the wiring harness now. Connectors are sourced from the pre-agreed or your approved vendors. It can save significant cost incurring at site. Besides, time delay can be saved. It can reduce site wastages. In our estimate, over 10% is small pieces of solar cable is left behind, and it reduces installation cost due to plug and play model. So very soon, I think in India also this concept is catching up quite fast. So these are some of the examples of the type of harness which can be offered by us. And I think by and large, all of you know, we are predominantly present in the major renewable industry, and we have a significant exports to USA, Australia, Middle East as well. These are some of the footprints where we are selling our solar DC cables. So you can see a lot of countries we are doing significant exports. And that's all I have to present. And thank you very much for your patience. I'll be happy whenever the organizers ask for any question answer session. I'll be happy to do that.
Thank you so much, Bajaj sir, for your valuable insights. I will take a moment to thank all our sponsors, Platinum Partners Longi Solar, Signing Electric, TVEA, Arctic India, and our gold partners, Apar Industries Limited. So, without wasting much time, let's proceed with our knowledge presentation by Mr. Varun Sachar from Asian Trackers Private Limited. Varun, sir, the screen is all yours.
Okay.
Yes, sir, you can present your screen.
Can you see my screen?
No, sir, we cannot see it yet.
How is it possible? Why is it there? No.
I would request other speakers to confirm if anybody can see the Varun sir's presentation because I am not able to see it yet.
Not yet.
Not yet. Pranjal.
Not yet. I think there's some net problem right now.
Not yet. Not yet. It cannot see.
Net का problem है.
So, please let me know if you're facing any kind of difficulty. Unfortunately, Varun sir, we are not able to see your presentation. No worries, sir. By the time you fix your network, we will move ahead with our.
Now, now, can you see me? Can you see my screen?
We can see you, but not the screen.
No, sir, we cannot see your screen.
Uh, I think something gone wrong.
Not a problem, sir. We can fix this, and I believe you are having some technical issue from your end. So the show must go on. So attendees, please make a note that please start posting all your questions in the Q&A box with regards to the presentation, and also we can take up the questions of the panel discussions. So, are we ready to start with our most awaited panel discussion? Attendees, show us how excited you are. Send as many as virtual emojis as you can. Let's all cheer up for the session experts. So thank you so much for the emojis and the motivation. So we should start with the panel discussion. Okay, so let's go now. Thank you for the emojis, and it's time to begin with our first panel discussion on engineering innovations, understanding the latest technology trends. Session experts who has joined us today are Miss Monica Rathi from Vena Energy, and she's also the moderator for today. Mr. Siddharth Sen Gupta from Semcop Green Infra Limited, Mr. Alan Kaur from Cleantech Solar, Ms. Harshita S. Kumar from Larsen and Toubro Limited, Mr. Manohar Das from IBVOGT, and Mr. Bharat Kumar Meghwal from Sening Electric Co-Cooperative Limited, and also we have Mr. Manoj Gopalan Nair from Enphase Energy. Now, I welcome all the panelists on the screen, and would like to hand over to Monica ma'am to take the discussion forward with other speakers.
Priyanka, I think, can we start?
Yes, 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 sure.
Can you see the screen?
Yes, sir, we can see the screen. Fortunately, we can have your presentation now. After that, we'll
So, can we
continue with the
start?
panel discussion. Sure, sir.
My apologies to everyone. Sorry for the delay. Okay, I am Varun Sachar. I own this company called Asian Trackers Private Limited, and I go with a big saying said by Albert Einstein that imagination is more important than knowledge. Knowledge is limited, imagination encircles the world. That's the philosophy which we also like to follow. Give a small background about ASIN. ASIN company has got following companies all in the domain of solar. We have ASIN Solar Power Private Limited, which is doing EPC work for rooftop. ASIN Trackers, which is a company, which is a technology company, which has developed a new and enhanced solar tracking system. We have another company called Intellotech AMC Private Limited, which is for remote monitoring system and O&M services. And the other three companies are the solar assets what we own at various locations across the country. Now, there is a concern in the solar industry, and the major concern is like due to the depleting solar power tariffs, which has badly increased the levelized cost of energy and reduced the project and the equity IRR, thus making it highly competitive. This became a serious concern with many of the investors as well as the developers world over. And the possible solution to mitigate these challenges was to reduce the levelized cost of energy by improving the CUF, by maximizing, and that happens only by maximizing the yield. The number of technological innovations were done over the last few years, which could have improved the performance, which had improved the performance. Some includes like the improvement in the solar panels. If you look back 5 years ago, we started with thin film, then poly, then mono. Now we have got bifacial modules. The sizes are changing from 300 or 200 watt peak to 600 plus. Today we are talking about inverters. A lot of technological improvements have been happening in the inverters. So all these things have been contributing basically to increase the CUF, you know, and obviously optimization on the bills of material, plant management. These are all factors which are counted into it. But there's one area which has been slightly ignored, that is the MMS, the module mounting systems. And I would like to focus only on the solar tracking system because this is one particular MMS which can enhance or which will enhance the yield. And unfortunately, it is not very popular. It has never been very popular in India, unlike in US and Europe, because of many reasonings, mainly because of its cost, O&M, and not getting the desired yield. Therefore, this technology also required some innovation or disruption on the existing tracking systems, which could harness the sun with more efficiency and effectiveness. So this is basically what our prime objective was, and this is what we wanted to, solve the solution, the problem, and give a solution to this. So how will we give this solution is by removing all the shortcomings which are there in the existing single axis tracker, which, with due respect to everyone, but with more advanced and innovative technology which allows the module to harness the sun more effectively and efficiently throughout the day and during all seasons of the year. Mark my words, sir, during all seasons of the year, which is very important. The desired technology also keeps the angle of incidence of the sun radiation perpendicular to the solar PV module at all times. So when the solar radiation is perpendicular throughout the day, obviously the generation will be higher, and higher generation will lead to higher yield. Now let's talk about the existing tracking technologies which are there prominently used in the market. Is the horizontal single axis tracker, and the number of studies have proved that this tracking technology does not give significance consistency in all seasons of the year, particularly during winters and the transitional period of the sun, because the angle of incidence is not maintained at right angle at all times. Therefore, its effectiveness is restricted only during summers. I'll show you a graph that it affects later. It has also been proved that it is least affected during locations above the Tropic of Cancer and below the Tropic of Capricorn. Therefore, the usage is limited to locations only closer to equator. Well, these are our observations, and this is what our statistics shows. The other technology which is existing in the market is dual axis tracker. This undoubtedly is an ideal solution, but unfortunately economically unviable because of its high capital cost due to a heavy structure, complex design. So single axis tracker does not provide the desired yield, whereas dual axis tracker does not match the economic viability. So these are again the problem areas. Considering the shortcomings in the existing technology, disruption in technology is required with a disruptive solution. So a detailed study of the sun path is required for harnessing the sun to its optimum level. So let's try to understand. Let's go back to our drawing board and see how does a sun path. This is a small image that which shows the sun path in the northern hemisphere. The yellow arc which you see is the summer solstice period during summers. You can see the arc which is the sun takes a longer time to set, and it is right above the earth. The blue arc which you see is the winter solstice period when the sun has moved down towards south and the duration during the day is lesser. The orange arc which you see is basically the equinox period, the transitional period. There's the sim and the spring and the autumn. So these are the three basically sun path. The yield from solar PV modules is dependent on the angle of incidence of solar radiation. That goes without saying. The longer the angle stays near the perpendicular position during the day, higher the yield. So this is the philosophy which we have followed, and this is the entire research is based on this philosophy. So what is the solution? The solution what we have, which is a newly designed solar PV tracker which moves the module on two axes, that is east-west and simultaneously from north to south. It follows the sun path on daily basis as the seasons keeps on changing, unlike the single axis which has got only one directional movement. Our enhanced solution maintains the angle of incidence at nearly perpendicular position at all times, thus harnessing the sun to its potential. So this solution, we have called it as a two-axis solar PV tracker. In two-axis yield is positive, but yes, there is a yield which is much higher than the fixed yield, irrespective of any season, whether it's winter solstice period or the equinox period. And the SAT is either at par or less than the fixed yield. This is why the average yield in a year of a two-axis tracker is 2 to 3 times higher. These are the statistics. This is what we have worked out. So any location which is above the Tropic of Cancer, which above give you a yield of more than 2 to 3 times. So yield gain is consistently higher in two axes on daily basis, whereas it is inconsistent in SAT. So I can prove this with the graph which I'll show you later. So we talk about the disruptive technology. So ASIN 2-axis tracker is enhanced and completely new technology which replaces and disrupts the existing single-axis tracking technology, hence rendering it obsolete. It is designed to succeed similar technology all use. This is that is in use. So this is the solution which for what we want to provide to the market. And how does it look like? This is what is called. This is how it looks like. The modules are installed at a distance to avoid shadow and moves from east to west, and the entire table moves from north to south. So it has been seen that the increase in the yield has been 30% over SAT depending upon location and climatic conditions. And this design, well, we went with this concept to IIT Delhi, and then IIT Delhi has done the engineering drawings for this, keeping all safety factors into account. Small like design advantages. This and mechanical design of this axis tracker developed in collaboration with IIT Delhi automates the daily east movement of solar PV module as well as seasonal north to southwest as well as shifts simultaneously, thereby offering optimal yield. Design with low capital cost while offering high industry standards cost wide and with low tolerances. This is designed with arrays for or offers higher plant central availability, use of self-lubricating polymer bearings for minimum maintenance cost, IoT ready remote monitoring system, and extremely effective design for our bifacial modules. This design is very, very, show you a slide on that also. This is project which we have. This asset what we own of megawatts in northern India. On the left side, you will see fixed hill. And on the right hand side top, you will see a single axis tracker where we got the technology from Europe. And in front you will see the 2-axis tracker. And this entire plant is on CCM computers on picked up the string inverter best performing. This will be a string inverters and compared it with the 2-axis tracker. And the results are these. This is the result what we got. We monitored this performance on day-to-day basis. The yellow line which you see on the graph is of 2-axis tracker, which is always the 2x higher than the MMS which are located in that particular location, in that particular location. That particular. The blue is the fixed tilt. The orange which you see is the single all-axis tracker. Now, what I'm trying to prove here is that when the sun, the transition period, that is during the equinox periods, somewhere around in February, March, and in October, they almost come at par with the fixed tilt. And during it goes below the average. Let me try to explain the same graph with a bar chart. We're keeping the performance of the fixed tilt as delta. So the which is in for the single axis tracker for the month of November, December, and January, you will find it is below than the fixed tilt installation, the yield for the fixed tilt installation. And during February and October, it is almost at par. And whereas 2-axis tracker is always positive, it's always higher than the other types of MMS. So this is the graph which I wanted to highlight the most. What are the USPs of the product? What our innovation, unique features in 2-axis tracking technology overcomes the inherent design disadvantage of the horizontal single-axis tracker. 2-axis tracker movements along the sun path maintains the angle of incidence close to 90 degrees at all times. It translates to a superlative yield performance close to a dual-axis tracker at the cost of a single-axis tracker. This is the punchline which we want to specify upon. And with improved yield, it justifies undoubtedly the enhancement in the CUF of the solar power plant by at least 2 to 3 times gain over single axis tracker. And the gain is always available across the globe, irrespective of the location. So any location which is below the Arctic Circle and above the Antarctic Circle, performance of the 2-axis tracker will always be higher than the single-axis tracker. And it will be around 20% plus. Another important feature is its mechanical design, which is decentralized in nature and lubricating bearings. And the other most important, which I want to highlight, is the unique design, which is very, very beneficial for the bifacial modules, which gives a very better performance. I'll show you that slide as well. And this is what is the bifacial module. So there are two, reflections. One is the sun reflection, which is falling between the modules, falling onto the ground and taking a reflection back onto the bifacial module. And the other is falling on the module, on the top of the module, and the reflection is on the module and the reverse of the adjoint module. So this will give my performance. So a team which has developed this is by Dr. Mukherjee, who is the technical director, and he's the dean of IIT Delhi. He's faculty at IIT. And in fact, has also a PhD from Ohio State University, and he's the co-inventor for this 2-axis tracker. We have Mr. Nilanjan Sen, who is also an IT from Delhi, who's also a co-inventor. And we have Mr. Varun Bhagat, who is an employee in the company, and he's from IIT Roorkee. So this is a small introduction I have to give about the company and the product which we have developed. So what we say is that with the depleting tariffs world over, ASN Tracker has got a right solution by innovating the right product at the right time with a disruptive technology by overcoming all shortcomings of the existing tracking systems. Thank you very much. So any questions? You're welcome, please.
Thank you so much, Varun sir, for your insightful presentation and setting up the tone for the panel discussion. I would hand it over to Monica ma'am to
Priyanshi?
take the discussion ahead.
Thank you, Priyanshi. It was pleasure hearing both the presentations. In fact, I would start by saying that right engineering design probably forms the backbone of solar plant. And with the solar tariffs in the last 2 months hitting almost 2.14 rupees, can I request speakers who are not talking to mute themselves? There's a little bit of background noise. Thank you. Yeah. So I think with the latest tariffs almost hitting 2.14 rupees per unit, it has become even more imperative. And I will use the language which was just used, right technology designs at the right time and with the right mindset, right? So what is the right technology which will help us techno-commercially help achieve this goal of hitting the lowest tariff? That is what is going to be the focus for this session. We will essentially be highlighting what are the new trends in module, and there is a lot of variety that we could choose from: inverters, possibly trackers, and other innovative solutions maybe on the transformer side, on the overall system design that is helping achieve such tariffs. So it's my pleasure to be moderating this session today. I welcome all the panelists. I would start by focusing on the heart of the solar system, which is essentially my module. In 2021 specifically, we have seen multiple module technologies coming into the market, right? With highest commercial capacity probably that is available is to the tune of 660 watt peak, whereas till last year we were still somewhere between 450 to 500 watt peak. Today, developers also have a variety of choice to pick in terms of the bill of material itself, right? So whether it is picking up the right efficiency module, commercially available probably between 21 to 22%, and the newer versions we heard going up to about 24 to 26%, or picking up the wafer size where we have seen movement happening from maybe a 166 wafer, which was 400 to 450 watt peak range, to a 182 which is again 500 to 550 watt peak, and now moving towards maybe 210 again, certain specific vendors who are getting into the 210 wafer size. The technology itself has many options. We heard bifacials coming again and again. We have been talking about half-cut cells, maybe multi-bus bar technologies with a combination of mono-PERC and even the heterojunction technology, right? So there's a lot of decision that needs to be done on module, which will help us optimize the BOS cost, as well as reduce the overall LCOE. Now, with this as the background, at least on module, let me start our panel discussion by asking this question on which is that module technology which will help us win the levelized cost of energy game. So maybe let me invite Siddharth Singh Gupta from Semcop to share his thoughts on this topic. Which is the module you think makes the cut? Everyone has been talking about bifacial, but is this the technology that we should be betting on? So Siddharth, if you can start by sharing your views.
Thanks, Monica. Thanks. See, we have seen a very big revolution in evolution in module technology as well as cell technology. I divide into module technology and cell technology as two different distinct things. See, when we started our journey, we have seen modules with the 36 cells. Way back in 1998, 99, when I started my career, I was working on 36 cells, 72 cells. And then now, because of half cut, it is 144 cells. And now people are increasing number of cells, maybe 172 and so 178 and so on. Now, it has two impacts. One is the more you increase the cell numbers, your voltage is increasing. The moment your voltage is increasing, your number of string getting reduced. in the system per se, because module current is a proportional to the cell area. Voltage is the number of cells you are connecting in series, isn't it? So the ultimate gain is how I can extract more energy from the given area of module, and how my total BOS cost can come down so that I can gain in the LCOE. This is number of cells what I talked about. Apart from that, we have also seen that single junction box now has become a split junction box. Now junction box has come into the middle, apart from the top. The traditional that has given a gain on the the voltage drop of the bus bar. We have seen half cut cell, one third cut, even one third cut cell now started actually. So the half cut cell, what is the advantage? Half cut cell advantage is the more you cut the cell, your voltage is increasing one thing, but your bus bar voltage drop, because when you are traveling, when you are capturing electrons, so you are also having a voltage drop across the the bus bar in the ribbon. We call it ribbon, the front ribbon. So by cutting by half, you are reducing that voltage drop. So you can observe that by doing the half cut cell, you are gaining one bin. That means straight away 5 watt gain in the module wattage. So 530 will become 535. So apart from that, also we have seen that number of series and parallel of the changing of the series and parallel, then reducing the gap of the cells so that the packing density increases. So and so on. Then another technology which will be coming in future, which is the shingles technology, where there is no gap. It is cells on cells. Now coming to the cell technology. Now we have started with mainly the P-type wafer with a boron dope. And then we have sliced into the wafer, from the ingot to wafer, and then wafer to the polycell, and then monocell. There was a pure monocell, there was a pure polycell. Now the PARC technology has come, I think 5-6 years back, and that PARC technology has given us a lot of gain in terms of efficiency, and also lot of reduced, in terms of your losses. I'm talking about the cell-related or module-related losses. So now PARC has two types. Now we started with the M2, M3 cells. Now we are reaching at M6, M10, and now M12. People are talking about M12. So there are plus points, there are minus points. When you are increasing the cell size, they're increasing the module size also. When you are increasing the module size, then there is a problem of handling at the site. Already India has started facing that, because look at in India and what is the difference between India and the abroad, the developed countries. We use a lot of cheap labor manpower, semi-skilled, unskilled labor manpower at the site, who transport the module by hand. So when it is a much bigger in size, they sometimes face problem. And there is a micro crack happening at site for a bigger site. So there are pros and cons, in both the things. Apart from that, now from P-type, when we are seeing that, when we came to PERC PARC technology, we have seen that LID, the first year degradation, has jumped up. Why? Because there is a light induced degradation and then light elevated LETID. They are both the things. Now, why it was coming? Because of boron impurity when you were making a PN junction. So by doing that, now Longi and all big players have moved to gallium doping instead of boron doping. So now you can see the first year degradation, when I started my career, it was 3%, the first year degradation. Now it has come down to 2%, but I know actual degradation is around 1.2%. We have seen in the field report. Now that has come, now P-type has changed to N-type, because the moment you put the N-type with the phosphorus doping on the top, your LID has become almost negligible, isn't it? So that's an advantage. Plus, people are also experimenting with module material. I'm talking about people are now using POE instead of EVA. POE is much better material in terms of moisture trapping, So that means you are gaining in the degradation. So when I started, I think earlier it was, Monica, you remember 0.7% was the degradation, 0.6, 0.7. Now people are talking about 0.5, 0.45 degradation. Now we are talking about double glass or transparent backsheet because of bifacial technology. So ultimate, lot of experiment is happening. There are pros and cons, but everything comes with a price. So when we do the LCOE calculation, we look at the generation. There are two main technical input goes into financial modeling. One is your generation, another your capex of the plant. The capex of the plant depends on how good you are making your plant configuration, whether you use a string inverter or central inverter, or how you are putting your module 540 module or 600 module or even 450 watt module. So all these experiment we always constantly do as a IPP, and then we come out with the best LCOE, levelized cost of the year, and then we bid. So that's in nutshell. I just described everything.
Thank you, Siddharth. Though you covered everything on modules and cells, I still did not get my answer, which is the technology which makes the cut. But I hear you. I think it is very site specific. It is not just one plain simple answer, because there are a lot of parameters which go into both the technical as well as the commercial side to be able to make that decision.
Absolutely.
Maybe let me change gears and ask this question to Ellen, who is joining us here from Clean Tech. Ellen, what are your thoughts on the module technology, specifically with higher watt peak modules, right? Earlier, it was a given that the moment I have higher watt peak modules, my overall BOS cost is going to reduce. But with higher watt peak today, I actually have a larger module, and hence the weight is increasing, the size is increasing. Um, what has been your experience? How is it balancing out in terms of the BOS cost? And second, what are your thoughts on the inverter? How is module and a inverter combination working out? What are the trends which will make the difference in this year?
Yeah, I think by the way, Sida did a very good job covering the technology, so I don't have to cover the technology. All I want to say is, unfortunately, yeah, very often, even as IPPs or installers or developers, we are technology takers. We're not really the trendsetters. The trend has already been set for us. If you look what's out there, the new modules are typically with either the M10 cells or the G12 cells. So M10 is 182 mm, G12 is the 210 mm. The main difference will be the G12 will give you a larger current and a smaller voltage, just for simplicity, right? And that is driving the module sizes to be much larger than before. The efficiency is not increasing too much, but the size is increasing. That has a slight benefit when it comes to your MMS and your labor, very, very marginal. I think the main benefit that we are seeing from the market is really that driven by the high current. So the high current is giving us a lot of the savings because the same 4 square millimeter or 6 square millimeter, you're able to drive more current. You're able to get some BOS savings. I think that is well documented, well known trend. And if you go by that definition, then your G12, being a higher current module, should give you a slight advantage. But of course, since especially since Longji is a sponsor today, we have to give the pros and cons, right? When you go with a G12 bigger cell, you have a higher chance of micro cracks and other associated issues. And we cannot forget that the industry is very small. Everyone knows each other's advantage. So often you can also see in the price of the modules. So whatever the savings you think you're getting, you think you did all your analysis, spreadsheet, done everything, and then you took the assumption the modules are the same price, which is not the case. Everything is factored in. I'm sure some of the people here worked with various thin film technologies in the past, and you will know they give you better yield, but all of it is factored into the price. So from that perspective, I think it's really clear. No one can say for sure, is it M10, is it G12, who's going to win, but there will be space for everybody, and it's really for us to capture the right time. And then moving on to your second question, Monica, also a very good one. If you look at the inverter space, what has a 182 mm and 210 mm done? What it has done is that the 182 is around 15 ampere, 210 around 20. If you want to add safety, maybe you need 25 ampere. So if you go with the central inverters, you have no problem. Easy. You just deal with it at the DC combiner box. But once you go with string inverters, then you are seeing that there are new inverters coming out from all the usual suspects with high current versions. Some are a little bit more suited towards the 182, and some are more suited for the 210. So it's really finding that balance, working with the right partners, and keeping track of what is the latest developments and release dates. Specifically for India market, we also have to deal with BIS, both for modules and inverters. So I think these are all the factors that we look at very deeply to make sure that we get the right compatibility. I have seen some players, what they have done is they have used a old inverter with new modules. And unfortunate outcome of that is you get what I call curtailment at the DC level. So you have a panel wanting to produce 15 amperes or more, but your MPP is limited at 12. So you naturally immediately lose almost like 20% of your power. I think these are the kind of issues as engineers we need to deal with. And when we look at the techno-commercial, it's really about balancing all of it and finding the right solutions. I don't think there is a one solution that works the best. I think the solution that I will work the best for me may not be the one that works the best for Monica and for the rest of the speakers. Yeah, thank you.
Absolutely.
Thank you, Alan. I think it was great to hear that you are taking care of the increased current values while designing the compatibility between modules and inverters. This brings me to actually one more point which we end up missing out. It is very critical to ensure that my modules and inverters, even from an operating voltage perspective, are compatible, right? We know that the inverter efficiency is dependent on the operating voltage. The MPPT, again, it's a combination of multiple MPPTs in string inverter versus maybe one in the central inverter. Um, how does this combination of new inverter trends from maybe a 2.5 megawatt inverter to a 4.4 megawatt inverter vis-a-vis the smaller string inverters, what are the pitfalls, I would say, in design that we need to take care of? I would like to invite Harshita from L&T, who has been with the design team, to give us some inputs around that factor. How do you look at the compatibility on module versus inverter, and what are your, I would say, tips for the design teams here?
Yeah, sure, Monica, and nice to meet you again in this forum. So, while we look at the compatibility between the modules and inverters, I think already Mr. Allen had nicely touched upon the issues which we are currently facing with high current, high wattage modules as well. So mainly three things is what we need to check. One is the system voltage. Definitely earlier we were at 1000 volt, now it is 1500 volt. So the module and inverter, the module string size VOC, will depend on the VOC, and accordingly we have to select such that it is at 1500 volt, and there is no, if it exceeds that, then there can be tripping and associated curtailment of generation. And second, we need to look from an MPPT window point of view, as you also touched upon. So the VMPP we should select in such a manner it is within the MPPT range of inverter, and accordingly ensuring a higher generation and energy production. And another parameter is the input current. The maximum input current, which will also depend upon the inverter inputs. The inverter number of inputs, the current rating of that particular input, as well as mainly from the fuse and MCCB point of view of the inverter. So all these parameters is taken into account while we are designing. And with the higher wattages, few of the modules are having higher current also, like few like Trina high current versions are also there, wherein then it impacts the number of modules in a string, as well as number of strings connecting either to the string inverter or to the string combiner box, and then accordingly the number of inputs to the inverter as well, or how much we are connecting. All these will get impacted because of this compatibility between module and inverter, which we need to take care as we are moving from, as you started in the beginning, as we are moving from smaller wattage modules to higher wattage with associated parameter change. As Mr. Allen was telling, central inverters, it was easy to adapt, but in string inverter, yes, we are facing some challenges, especially the number of inputs per MPPT or etc. That is also getting impacted. So, but I am sure the technology in inverter side also will adapt to suit for the changes in the module, and we can see better performances in future. Maybe very near future as well. So people are starting to adapt their products for such high wattage module also, and we will see more improvement further. That's all, Monica.
Thanks, Harshita. Thanks for those details. In fact, I just realized that we have Bharat, who is from Sinan. So it would be good to hear it directly. I mean, as they say, from the horse's mouth as to uh, how do how does Bharat, as an inverter, as a person with the inverter manufacturing, see what's happening with this change in technology? How is it impacting the inverter? I would say trend. And what are some of the new technologies that you guys are working on that we should be thinking about?
Thank you, ma'am. First of all, it's a great honor to be a part of this discussion with you, all PV experts. Yes, recently we have seen a lot of changes in module technology. Before we were using polycrystalline, now bifacial, monopile, such things. So with the evolving of the PV technology, inverter technology also has been evolved. And now the inverter has geared up to build the LCOE concept. Inverters are now outdoor and technically advanced. So here, if you see the advancement, now the inverter size is pretty big. 3.25 megawatt inverter, 4 megawatt inverter, 5 megawatt inverter also, to break down all the overall cost of the system. So first, to understand the implication of large wafer size PV module with the central inverter and string inverter, to understand the power increment with the increment of wafer size, as we all know that PV cell is a radiance controlled current source. So current can be increased either by increasing the irradiations or cell area. So we can say large the cell area, larger the current. And for now, utility project, the system voltage is 1500 watt. So the cell area will increase, but the voltage remains same because of this half cut technology. First, I will talk about the bifacial module. I'll take the example of bifacial module. Bifacial module is very recent technology for the Indian market. So there are such areas where we can have more and more generation from bifacial module. For those particular areas, distributed inverter is the best solution. The biggest problem we faced at the plant level to transmit the DC power at the rear end. So if in that case, if we are going to use the central distributor solution, which is the latest technology, by using this, we can take most of the power from the bifacial module and can utilize it and can convert into AC system. Okay. Secondly, I will talk about the monopod. So for monopod, here nothing to worry about the compatibility with the central inverter and the string inverter. As we all know, the maximum short circuit current of the central inverter is higher. So there is no constraint in array designing with the high power module. However, the input fuse and breaker rating of combiner box need to be adjusted along with the DC fuse rating of the inverter also need to be adjusted. So, second, I will take the example of a string inverter. What is the implication we face with the this high wafer module size with the string inverter? So, as everyone know, the last developed string inverters input rated current was very low. So now we saw the PV module capacity is bigger than 600 watt peak. So now everyone is changing and increasing the input current capacity. To support this high density module, we have also introduced our new string inverter, SP275K INH. This inverter can work with the all kind of wafer size. Let's say M10, M12, 182 mm, 210 mm respectively. So nowadays, not only we, everyone has the solution. So we can say that everyone can comply to this. Yeah, that's all.
Thanks, Bharat, for sharing this. Maybe I'll go back to Siddharth and Alan, and the question is for both of them. We have seen two sides of the coin, right? There are developers who literally bet by central inverter, and then there are developers who feel that the kind of additional yield that you get basis the string inverter, it makes sense to specifically to reduce the module mismatch, to have take advantage of the higher MPPT. It is better to switch off to string inverter. What has been your experience, and what are the pros and cons that you guys see of one compared to the other? So the question is open both for Siddharth and Alan.
Uh, let me first answer your question. Yeah, it's a long debate. It's a long debate for going on for last 3-4 years. Both have a pros and cons. String inverter, you have string level inverter. Okay, now central inverter, you have single MPPT mostly. Then you have, and people are not going into string monitoring box. They are going into zone monitoring. In the inverter level. That has a lot of minus points because you do not know what is happening into an individual string. You have to, unless you are going there and doing that. Earlier you used to select individual string wise, isn't it? 12 input or 18 input or 24 input. Now say string inverter, we are either we are using Y connector to make it one string and putting into a MPPT, or we are directly going into series connected module and going in directly into the MPPT channel. There are two MPPT channel mostly in par, yeah, and there are 12 MPPT, 12 to 18 MPPT. I think Bharat can make me correct. So there are a lot of plus point if I go for string inverter. Now, what is the minus point? Minus point is your cost might increase. But nowadays, I have seen that first of all, in PVCs you get some hike. For example, we get generally 1.5, 1.6% high when the moment we go for power sharing mode and the multiple MPPT option in the PVCs. Okay. Now, which you may not get that. Now, 1.5% extra yield has to be compensated by the price gap, between the central and string. But fortunately, the string inverter price also has come down drastically in recent days. And the string inverter also has increased. Now, we are getting 250 watt string, kilowatt string inverter. Earlier, it was much lesser. So, but if you ask me as a system design point of view, I always tell string inverter is always my preferable choice. Because in the big plant, even if you have suppose you have a local cloud on a big plant, so your half portion of module are shaded and half portion is under sun. And then you're, in a central inverter and one MPPT, you have, lot of mismatch losses. So you have to choose, as per the, techno-commercial.
Thanks, Siddharth. I think, one point that you made, that string inverter is also becoming bigger. And we sometimes joke that looks like the gap between string and central is going to go down eventually, right? Because string is also, in a way, moving towards that same direction. Ellen, your thoughts? Anything you would want to add onto this topic?
I think on this topic, the most important thing is we have to take a data-driven approach. So I'm sure each of us, we have our own test sites, we have our own data, and we follow what the data tells us. If it tells us that the string inverter is giving you 1% more yield, then you'll run the numbers and you take a decision, which is better, which is worse. And I think from that perspective, it's very clear. The market sends the signal, the inverter manufacturers, they respond with their price and so on and so forth. So my perspective is quite clear. I think this part of the world, it appears to be shifting towards the string inverters. But if you look at the US, we have some colleagues there, and it's a clear central inverter market. So there's no one size fit all. I think there's a lot of various parameters. It depends also on how comfortable our local teams are to service these inverters. So in fact, if they are not comfortable, then they tend to go to string inverters because they are easy to replace. And if you have a very strong network, then it tweaks a little bit. So I think, again, and I have my view. I have a general preference, but what I have seen is it varies very drastically. And the key thing here is about the service support. and finally how you run those financial numbers to get the best LCOE. Because at the end of the day, what really drives the business is always the LCOE, unfortunately or fortunately.
Thanks, Alan. I think interesting perspective. I'm sure a lot of us have data from the field, which can probably help us reconfirm the numbers that we get from PV Syst versus what we see in actuals, and which can help drive these decisions. One more interesting trend that I've at least been seeing or observing in the market is not necessarily for utility scale, but there's a lot of talk around micro inverters, especially on the rooftop side. I see Manoj, who is part of Enphase, here with us today. So, Manoj, a question to you: how do you see this trend happening in rooftop with micro inverters, and do you see it also becoming probably mainstream in the utility scale? I mean, just maybe if you could share your thoughts on what are the advantages and how we should look at micro inverters from that perspective.
Thank you, Monica. Micro, I've heard about the string and Sendal from all the speakers, almost all the speakers. None of them have spoken about the micro inverter. So we are, in terms of the technology, we probably might be a late entry, and the conventional systems are still designed around the strings. So the difference, answering your first question on the technology advancement side, the micro inverters offers much more advantages in terms when it's a system has some challenge and the shade. I heard Mr. Siddharth spoke about the shading challenge. So since the inverters are attached at every panel level, and we are optimizing the energy generation at each panel level, and it's a parallel system. So it is not like nesting inverter. All of us know that one panel gets affected with the shade, the entire system output at that string comes down to the lowest generating panel. And by virtue of we generate the energy generation panel to panel, we see that at least about 10% on an average in a shared system we will have advantage. Even 15% we have seen in smaller systems. So if you look at the cost economy, the microinverters fares well for small systems and medium systems, because every panel we need to add a microinverter, the cost of the system increases. Even though we have an advantage of extra energy generation, and that get negated for a bigger system. It needs to be a utility scale of products. So our primary focus in the market is the small residential systems and the small commercial systems. So the advantage what we bring on the rooftop for small residential systems, if you look at in the US, we have moved to 56% market share in the residential sector in micro inverter category. So how did we reach there is because of the additional energy generation. We also have the advantage of a distributed AC system. So there is no high voltage DC on the roof. And in US and advanced countries, there is a rapid shutdown is a technology requirement from the government regulations. So if there is a fire, typically the first thing, the fireman goes try to approach to the roof. But people cannot enter the roof. There's a 1,000-volt or 800-volt DC system. But the system cannot be shut down for a string system. Whereas for a microinverter, just switching off the system, the system is shut down, because every panel, the maximum it can produce is 50 to 60 volt. There is no accumulation of voltage. This is another advantage which we brings to the smaller systems. Next thing is a smaller system for residential rooftop. People like modularity. I have a house. My requirement is only 5 kilowatt today. I am buying new gadgets and new ACs. I need to move to 7 kilowatt. The same system can be extended by just adding additional panel and additional microinverters. That's another system. The value addition we bring into the technology. Then lastly, on the reliability side. So these products, microinverters, are warranty 10 years in India. For globally, it is 25 years in the US, and we are also extending the warranty up to 24 years in India. It comes in IP67 box, and we don't repair it. We just replace. Our failure rate, one of the lowest among the inverter. So these are the aspects when you look at the technology advantage of microinverters getting adopted into the small to mid-size systems, and it's very easy to implement. It's each panel level we can monitor the generation at any point of time. That's another advantage. And even if a panel gets faulty, it is easy for the homeowner. We have an app on the phone. Homeowner can easily find out, okay, out of the 15 panels or out of the 200 panels, which are the panels not producing? Why is it not producing? All the other panels are producing. Is there a shade? Is there a soiling challenge? Is there an O&M record? These are the advantage of this. Preventive maintenance can be achieved through implementing microinverter.
Thank you, Mr. Manoj. It was
There is no mismatch in microinverter. That it is an AC module.
Yes.
It is an AC module.
Yes.
That's a fantastic.
I wish we, I mean, I'm sure that I think 700 watt peak modules have already been spoken about. So it won't be much time before we probably start getting somewhere to the tune of 1 kilowatt peak. And that is when I think the microinverters would make the best sense. It is a single kit that you could probably use at your home, where you could have one microinverter sitting with a module. So interesting concept. We have spent a lot of time talking about modules and inverters, but unfortunately, there is a lot of other components which will ensure that my BOS cost or my LCOE stays at the lowest. There has, in fact, over the last few years, I would say we have seen switch over from copper transformer to maybe aluminum transformer, cables getting switched to aluminum cables. I will like to open this up to the rest of the team as to what are some of the other ideas that you have been thinking of, things that you have seen happening around. Few things that at least I have seen is people have started, of course, talking about can we use cable hangers for rerouting the cables, maybe cable trays, not necessarily the steel ones, but at least the concrete ones, which can make the O&M of the plant easier, maybe can be used very well in sites like where water is there, be it Dholera or be it Radne Sedra. People have started talking about alternative material for MMS. And I think it started off with HDG, Galvalium, Magnalese, POSMAC, right? I heard a lot of people talking about FRP based MMS designs coming into play. So opening up to maybe Harshita, Alan, Siddharth, and Bharat to add more on what are some of the other innovations that either are happening or which is on your wish list, right? Which is probably not out there, but you would want it to be merged together so that we can take solar to a next level.
Yeah, very good topic, Monica, to talk on because we are in an industry where the cost and value engineering drives everything else. So the cost drives us to do more and more value engineering. So I belong to an engineering team where we have other business units as well, whether it is substation, TL, both domestic and international. So my counterparts are not at all bothered about value engineering. So they have a set design from the customer. They just need to meet that set design. Concept design is from the customer. They just need to do the detail engineering to meet that conceptual design, because it's happening for decades now. But solar is an industry where it's so dynamic. Every 2 days, new technology comes in, new price changes comes in, module price goes up, especially now when the module price is at the peak for the past few years. So what we are all trying is how to reduce the DC capacity as much as possible. So how do I increase the per unit generation from the given area and for the given capacity? So when definitely I feel one thing which everybody will be focusing now is how to see how to reduce my DC capacity considering the module price right now. How do I generate more? What technology I need to adopt so that my DC capacity is coming down. So that's why even though bifacial tracker was not considered in India till now, and it was very much if like I take care of both international and domestic engineering. So any tender we quote or the around 2 gigawatt of projects we are executing now in international, everything is bifacial tracker. There is no thought process at all about monofacial or fixed tilt structures at all. It's always bifacial and tracker based systems. So in India, I have been seeing for the last 1.5 years, there was when I joined engineering. So at that time, there was no talk at all about bifacial tracker. Maybe 1 or 2 developers may be thinking whether it is useful or not. But I'm seeing now many people have started talking on bifacial tracker, and I feel that that could be one, considering this module capacity, that could be one way of bringing down the LCOE by how I can generate more in a given space with lesser capacity. That is definitely one area to look at for all of us as an industry. What new technology we can bring in within that, like by facial tracker or something else, which can increase that generation. Second area which I would like to touch upon is with the past experience of Corona and COVID situation. One another key factor which will impact our industry is the labor availability. So this is not only impacting solar industry, but it is impacting the construction industry as a whole. We are not having migratory labor. We are not getting labor, skilled labor. Earlier, we are dependent on migratory labor who are coming, skilled technicians and laborers who are coming from far away to the site. We bring them from Punjab, from West Bengal, anywhere we bring them, fly them down, and then we execute or through train, etc. But now nobody is willing to travel. Everybody wants to do within their own area because of various COVID restrictions. So the execution cost or execution timeline challenges to execute a project on time and avoid LD also will become challenging, I think, going forward, considering this kind of scenarios. So how do I mechanize as much as possible? How do I automate so that my dependence on manual labor will come down? Will also be a key, I feel, personally, going forward, especially earlier as we started this in this industry 12 years back. The capacities was very small, so maybe 5 megawatt was a big project at that time. Now we are talking about the largest project currently what we are executing is 1.8 gigawatt, which is unthinkable scale if we even talk maybe 4 years back. So how do we do that? And the timelines have not expanded as per the capacity. Timeline still remains as stringent, which is the biggest problem we have been, or maybe the biggest challenge or opportunity as solar we have been facing for the past years. So that remains even with this such higher capacity. So to execute even this high capacity within this short time and with these challenges of labor, any mechanization automation efforts will also help, I feel, going forward. So I personally believe these are the two areas which we as an industry should focus on, apart from the continuous value engineering, what you were telling, like aluminum transformers, all these incremental value engineering definitely will add value. That's all, Monica.
Thanks, Harshita. In fact, I think you brought a very good point that we end up sometimes ignoring the soft aspects, and construction and digitization of construction and automation of construction, I think, is going to become important and as we move forward, specifically in this world where COVID is here to stay. So, Ellen, what are your thoughts, or what are some of the innovations that you are thinking of, and how critical is it for you to also bring down maybe the DC, as Harshita had mentioned, right? I mean, is tracker is the way to go just because of the increasing module cost? We even heard one speaker talking about dual trackers. So does it still does it even make sense, or single axis trackers, maybe with a combination of bifacial or fixed tilt, not fixed tilt, but bifacial or monofacial will make sense? So what are your thoughts around that?
I think we look at the market, we scope the market. The predominant MMS is either the single axis tracker or a fixed tilt. Fixed tilt, everyone in this forum, I think we understand it really well. So for single axis tracker, the benefits are clear. You do get more yield, and in doing so, you can raise your capacity factor, which is something that some of us have to deal with a lot. And then you add bifacial, you get a little bit more yield. The challenge then becomes you have to balance between more yield and also how much land. You have to balance between the additional MMS costs. Fortunately, at least based on the data we've seen, the maintenance issue seems to be not so serious. So if you ask me, I think based on experience everywhere, based on a lot of data, even our own data, we are seeing that a lot of areas you are going to find that single axis tracker is going to be worthwhile. The question mark is whether bifacial will be worthwhile. Specifically in India, you'll find that a lot of sites, the soil is a little bit dark. Dark means it doesn't reflect light as well. So if you are in like a Rajasthan with sand, I think it's a no-brainer. You go with a bifacial. But elsewhere, you have to think about these other topics. And Specific to India, I think that's the other issue that some of us may have already start to face, which is water shortage. I think that is something that a lot of us are starting to see or starting to think about. So that brings on the robotic dry cleaning piece. I think that is another key area that we will see start to get developed. There are a lot of players, some international, some local. Not very, very clear who will come up tops, but there are only a few that are there. So I think that is another key innovation that we'll see really, really take off over the next several years. And then if you look at immediate value engineering, then you have to see where the cost has gone up. Modules have gone up, steel has gone up, but probably not as much. Copper has really shot up. So as engineers, right, once you have a problem, you have to find a solution. That's why Monica was saying aluminum. I think that is also the copper price is what is accelerating this change. I think we've seen actually a lot of the major plants are done with aluminum already, but now everyone is looking how to do that. And that could also give certain technologies some slight advantage due to either the higher voltage or higher current. So holistically, I think the industry's problems are quite the same. You need to achieve high capacity factor. You need to make sure that you have water to clean. You will need to look at the life cycle cost, and we need to deal with the immediate challenge, which is that commodities have gone up. Module prices are at almost all-time high, and the water. I think that is the one that really hits us when we least expect it.
Thanks, Ellen. I think great point in terms of the robotic cleaning, because we do see a lot of switch happening both for plants which are under construction as well as for a retrofit for the existing plants, where people have actually started looking at how do they switch from water-based to non-water-based solutions, right? So what we will probably now do, because we are almost at the end of the panel discussion and we would want to hear certain question answers, Twinkle, maybe we can open this up for question answers from the audience, and we can probably take up the Q&A.
Sure. So I will show the question on the stage.
Alan, do you want to take that up?
Sure, I can take that. I think if you look at the dry cleaning technology available out there, they have shown very, very good results. We've seen that. The challenge that we have seen is that you need to keep doing the dry cleaning. You can't have long periods, because what happens is when you have long periods of gap between the dry cleaning, then the dirt will build up, it gets stuck, and then your next dry cleaning cycle doesn't work as well. So it has a lot to do with what is the frequency that you are doing your dry cleaning. If you are doing once a month, then probably yes, your wet cleaning could help to get rid of the dirt that is stuck. However, if you're doing very frequent, I know some plants they say they are doing nightly cleaning, dry cleaning, fully robotic. Then within that kind of situation, you probably will not benefit too much from wet cleaning. I hope that answers the question.
Maybe I'll just add one more point here. So a lot of plants which have been built in Rajasthan, they have actually kept alternate dry cleaning solutions, right? So something like, and I don't want to name vendors, but at least what have been used in the Bhadla areas are a combination of Ecopia, Solbright, Bosons. And there, no wet cleaning has in fact been planned at all, because the frequency of the dry cleaning is so high. The soil is more or less sandy. So if you continue doing maybe alternate day or every day or once in 3 days, you probably don't even need to do any kind of wet cleaning. So that is where we are. Siddharth, what has been your experience in your plants?
No, I think wherever we have Rajasthan, we always have robotic cleaning, okay? And we use almost every day sometimes. We do not use any wet cleaning, Monica. It has to be only dry cleaning, only the frequency will change.
Very good. Priyanshi, we can probably take up next one.
Yes, we are taking one more question since we are short on time, so we'll just take one more.
I think this we have already answered, Priyanshi.
I'm so sorry.
So I can handle this, but if there is anybody from the panel who would want to take a shot at it first.
Yeah, there are. Monica, can I?
Yes, yes,
Yeah,
go
yeah.
ahead, Harshita.
Yeah, there are definitely there is a cable tray solution which many of the projects we have implemented. But then yes, the cost of cable tray definitely is higher when compared to a normal cable trench, buried cable trench. So another solutions which are coming up is cable hangers, as the question itself asks for. There are solutions which where the module cables and certain string cables can run along the MMS structure using a specialized cable hanger solution. And otherwise, the joining the cables from up to the string combiner boxes, etc., also through a cable hanger solution with an wired support and associated foundations, etc., steel structures.
We are losing you, Harshita.
And some unique solutions, and then the cables with innovative solutions are also now people are adopting, EPCs are adopting. So definitely there are solutions. We have also done few in our projects of cable hangers, and we find that it's a good, especially if we are forced to go with cable tray. When compared to cable tray, it is definitely making a lot of economic sense to go with cable hangers. Only one, from an engineering point of view, one thing which we need to take care is the sun exposure. Even though we are going for UV, high power current carrying, high power cables like the DC cables, etc., we need to also look at the power duration which happens due to exposure to sun. So there are we need to take additional duration factors, and the cable sizing may slightly go up if we really are looking at a 25-year life cycle when we are exposing those cables to sun. So that alone has to be taken care, because in a cable tray you can give a cable cover, but when you are going for a cable hanger, the covering part becomes a challenge. So if you are not putting in a conduit and you are hanging it just like that, the duration factor with respect to IEC, and there are many publications available in IEEE also which say that with sun exposure, the degradation of cables is much faster when compared to even if it is a UV protected cable which we are providing. Yeah, thank you.
Thanks, thanks, Harshita. One more thing, addition to what just Harshita mentioned, there are these not necessarily the steel cable trays, but pre-cast or the concrete cable. I wouldn't even call them as cable trays, but these are more like cable blocks, which were earlier getting utilized mostly on the MV AC side, but of late we see a lot of this happening on the LV AC side. DC cables, of course, you would have them hanging along with the MMS, individual anchors or some kind of hooks on the MMS. So definitely, I mean, I would say terrains which are rocky, terrains where water logging is an issue, we have already seen this being used. And now the cost benefit analysis needs to happen whether it will make sense for the rest of the projects or not. So I think with that, Priyanshi, we are probably at the end of the session. It was interesting discussion with all the panelists. I was hoping to hear something more in terms of how somebody like us MCOP has been winning so many projects, but I think Siddharth did not want to give his secret sauce to us. But it was definitely an interesting discussion.
Absolutely. So,
Same.
thank you very much, all our esteemed panelists, for such an insightful session and extending your support for this event. Monica, ma'am, you did a fabulous job keeping the panelists focused, pulling from them great information, and keeping attendees engaged is no small task. You made it seem effortless. So we appreciate your time and efforts in making the event a huge success. And thank you all the panelists and a round of applause for all of you.
Thank you.
Thank you
Thank you
so
very
much.
much.
It was a
Thanks.
pleasure to have you all. Thank you.
Thank you, everybody.
Thanks.
Thank
Bye.
you, Monica. Very nice.
Thank you,
Thank
everyone.
you.
Bye.
Thank you, everyone.
Thank
Bye.
you, Rohan. Thank you, ma'am.
अरे यार, we were not about to take this break, na? Welcome back to everyone. Hope you had a great networking time. So, without wasting any much time, let's proceed ahead. Now it's time to have our last panel discussion for today. Before we proceed, attendees, come on, show me some excitement. You all are. So tell me, and you can hit the like button and cheer all our experts who have joined us today. That's wonderful. Your virtual emojis really motivate everybody. So thank you so much. Hope you all are having a great time. So let's proceed with our panel discussion on rehybridization, engineering aspects of solar plus storage. Session experts who have joined us today are Mr. Gurpreet Singh Walia from Green Ops Private Limited, and he's also the moderator. Mr. Sandeep Gurnani from Solar 91 Clean Tech Private Limited, Mr. Balwant Joshi from IDEM Infrastructure Advisory Private Limited, Mr. Sarvanan Moharan from Ayana Renewables, Mr. Amber Aziz from Sunsource Energy, and Mr. Vikas Arya from Solar Business Jackson Group. Now, I welcome all the panelists on the screen, and I would like to hand over the session to Gurpreet sir to take the discussion forward with other speakers. Over to you,
Thank
sir.
you so much, Priyanshi. Thank you so much. I welcome all the eminent panelists on today's session and all the participants also. So we have everyone. So let's get started. So, this month it was amazing news to hear that in India we have now finally touched 100 gigawatt of renewable energy, and it's a great milestone. I think it's an amazing feat on the industry colleagues, on the supply ecosystem, regulatory policy, all of them. I think a lot of thought, lot of innovation has gone into setting up these 100 gigawatts. However, it's not about to become complacent because the next 100 gigawatt is going to be very different. I think the shifts are very evident. As close as we see from the technology perspective of the last session, we have seen that, and all the experienced people from design sharing that when they started, where we have come in the terms of technology, and already we are hitting the new highs in terms of efficiencies and all of that. So in the next 100 gigawatt, it's very important that to keep a close eye on how technology is evolving. If you also look at the business models are changing. One example is to look at Reliance announcement of Giga Complex, right? The end-to-end integration of setting up batteries, solar panels, green hydrogen, all of those. So I think it's also not just about engineering; it is going to be about new evolving business models, which is very important. Add on top of that, varying market dynamics. Uh, Renew raising money from getting listed outside at NYSE, and SEBI considering more SPACs and allowing SPACs in India. I think this is going to open up another funnel for the capital to flow into these segments. And also the regulators, the way they have sensitized, and they are evolving with the technology. Take any of the round the clock tenders today, the intricacies and the detailing that goes into that, the very fine and tweaking mix of the tariff that is to be offered with the integration of non-renewable and renewable. And if you look at all these common themes, the where the industry is headed, one common blip, which used to be a blip on the radar and now is a mainstream thing, is energy storage. I think that is becoming very, very instrumental to all the things we are talking of, whether the new business models, whether the regulators. I think everybody has taken a very important note of that. I mean, 3 years back, we were having tenders like Andaman and other cases which were not, taking or seeing the success of the day of the light like other solar tenders used to be. However, if you look at today's tenders coming out, they're very, very different. So I think that is a enough sensitization from the market and the or the players in general. So that demands we look at energy storage from a holistic angle, we look at from an IPP angle, we look at from EPC perspective. We also look at C&I segment, because every time we talk about solar, we say that we have a lot of potential in the C&I segments. So how does solar energy adoption, how does energy storage adoption can happen in those sectors as well? So I think we have a very nice panel today to address all of that. We have IPPs, we have people who cater to C&I segments. So very nice. And let's begin with that. So I would start the discussion, ask two questions from each panelist, and I would let them expand and share thoughts on each of these topics, and try to large aspects that people answer questions that people and share designers, engineers also sometimes. So my first panelist I would welcome is Mr. Savanan Manoharan from Samhab. So you represent a large IPP in the country. We have diversified assets in solar, wind, all of that. We would love to know your views on what is the potential of the large format energy which hybridization the solar and wind assets that you have. If you want to expand on round the clock tenders which are coming, RTC tenders which are under this encouraging hybridization. And so, Seven and Seven, go to you.
Thanks, Gurpreet, for the questions. So I think since we are focusing majorly on the large scale projects, I think you have raised these questions which are more what to say, more related to our focus side or current area of working. So when it comes to potential,
over to you.
Yeah, could you hear us? Hello? Hello?
Yes,
yeah, we are able to hear you, sir.
We are able to hear you.
Yeah. So, I think there can be some network issues at your end. Yeah. Could you hear me now?
Yes, sir.
Okay. So basically, what I was telling is, I think that your question is majorly on the large scale IPPs, since our area of focus is on the large scale IPP. So as I understood, the first question is on the potential of the hybrid projects and the RTC in India. So when you see the potential now, the focus is shifting slightly from the standalone projects of wind, solar to hybrid projects. So you could have seen a lot of tenders coming out in terms of hybrid, and we have an ongoing tender which is on RTC also. So I think which is due for submission today, if I'm right. Okay. So basically, what is happening is already regulators and the grid operators are facing a lot of issues in terms of the grid network stability. There are issues related to frequency variations, voltage variations in terms of plants or parks which are where a lot of solar projects are closely located. So the shift or the recommendation from the grid operators also is to look at hybridization of this plant to ensure the intermittency nature of these renewable energy is somehow brought down. So, and there is one more shift which is happening, the round the clock tender, where already regulators are looking out on an firm power from these renewable projects. So as we see, it's a talk which is going on in the market. Probably when these tenders are able to get and competitive tariffs, probably there will be a change or shift from the current tender strategies, where people will go for RTCs and hybrids completely, with that, there won't be any standalone tenders of solar and wind. Because for them, we are already 100 gigawatt. And when we are adding renewable standalone projects over and above this, so the grid operators are already stressed, and there are a lot of network issues which has to be managed somehow. So they feel this is one of the ways to manage such issues by bringing in a lot of RTC projects where they have firm power flow on the network. That is one side of it. But and coming to the potential, you see, basically, we as we see, the competitiveness of this is there already when we hybridize wind and solar, which we have already seen in the last hybrid tenders. We have also won 450 megawatt out of the tender. But when it comes to RTC, still there is a lot of question marks onto it, because we may have to deploy storage to this, and battery is the only proven technology we have, wherein the competitiveness is a big question mark. When it comes to other technologies like pumped hydro, or people are talking about other terms of other technologies of storage, they're all not proven. So that way, in order to avoid probably the questions on reliability or the bankability of such storage solutions, the current current way or current only option available for the developers or IPPs is the batteries. Okay, so that's how people are all thinking about battery. But it may happen people will start doing with a high pumped hydro, probably with an existing project, existing infra also. The chances are very remote. So that's what we are seeing in terms of the potential. But the plain hybrid in terms of wind and solar, the chances are very high. Already the competitiveness is there. We already have 2 bits gone now. The upcomings will be still competitive. That's what we are expecting. So that way, there are a lot of potential, but RTC will take slightly some more time. So that's what we are seeing. Okay. And coming to the risk or the challenges what we face in terms of RTC, specifically hybrid as such, we don't see much challenges or risk. Probably when in terms of the design or sizing of the project, even convincing a lender and getting the lending approved for the project, we don't see a major issue in terms of a plain hybrid project when it comes to wind and solar. There might be questions on what is the scenario, whether we are considering P50, P75 or P90, but these all can be bridged, and the gaps can be bridged, wherein we can arrive at a conclusive solution for lending, and even that way the execution should not be a problem. Okay, but when it comes to RTC, we see the storage is a bottleneck. RTC, what we see is there are major 3 challenges we see in terms of an IPP. The first thing is the data and the analysis tools available. So as of now, we don't have a bankable tools available for designing an RTC system, or even that way an hybrid system. But for hybrid, even an Excel could be a good tool. So I don't see a major complicated or sophisticated tool that might be required for a plain hybrid. But when it comes to RTC, we may need it. So that kind of tool is as of now available. And there are a lot of issues in terms of data. As I told you, what should be the probability factor that should be considered for solar, wind, and battery. So battery as such on a larger scale, the deployment is very less, and the projects which are running on ground is very less. So that way, convincing the lenders on the bankability of the projects might become an issue. So that is one challenge we are seeing. And another challenge what we are seeing is the regulatory aspect of it. So the regulatory is still not clear in terms of, because we are all talking about non-co-located projects which can be hybridized to form or to bring an RTC in place. So when it comes to a non-co-located projects, we are facing a lot of issues in terms of how to evacuate the power, what will be the contracted capacity, what will be the long-term access that might be available for each of this project, etc., which even probably we don't have a clear guidelines from the regulators. So that could be another issue, but that people are working. I believe we will get a clarity as so. And the third one is on the market barrier. Market barrier in the sense, you see, we are getting a lot of products. There are a lot of sales engineers available for each of this product, but ultimately they were not able to say, so what is the capability of the product, how much capacity it can provide, what is the long-term access, what is the long-term capacity, there are a lot of gaps. Hello, there are a lot of gaps we could see, which we may have to assume to design the systems. That's what we see. And in terms of the application, you see, battery can be applied based on the application. For example, when you need a very sharp ramp off and fall in time, battery is the best solution in terms of storage, but that cannot work that way for an hydro or a pump storage system. So all these things to be thought of before we decide on the storage system. I don't think that clarity is still there in the market, or clear guidelines are not available. So all these things, so basically it is more like a situation where we started a solar 10-12 years before, and we have all been following the experiences from Europe and US, and slowly there were a lot of questions during that time also from the lenders, how this will work, what is the bankability of these panels, etc. So unless otherwise we have some projects working on field and delivering the desired results, so this questions will be there. So where we are here to, or to answer this, probably we have to take a lot of assumptions. Unfortunately, that is part of the process, I believe.
Great, sir. That was very insightful, and I think I won't be surprised if large IPPs start acquiring these small battery companies to obtain the in-depth knowledge, which maybe those salespeople are not able to trickle down to you. But I think that could be, again, it comes on a business model perspective, how you build those core strengths within an organization to deliver it on ground and not just on papers and Excel sheets. So from that perspective. Cool, amazing, sir. I think it was very insightful, and we will come back to you on a couple of things. Meanwhile, let's jump to Mr. Amber Aziz from SunSource. So, sir, we would love to know from you what are the key design criterias. Uh, am I audible?
Yes, sir, you are audible. Yes, sir, you are audible.
Yeah. So, Mr. Amber, we would love to know from you what are the key design criteria, that customers should be very sensitive about when they are choosing their energy storage solution provider. I mean, what are the questions that they should be asking or they should be looking at? Another thing is from a system integrator lens, when the people who are offering these solutions, who are not inherently the battery storage people, but they are integrating the system, what are the design considerations that they should have? So, Mr. Amber, over to you.
Okay, on behalf of SunSource Energy team, I'm very thankful to the organizers to give us a chance to speak in this forum. So first, I will take the first question. What are the key that customers should look into that system developer or a developer solution? I think that some of the most important thing or some of the important things are that any developer have done some project in past or not. That is very very important because we used to talk means there is a difference in technical or in what you say practical experience or theoretical knowledge as well as practical experience. So if somebody have executed some such project and run that project for a period of suppose 5 to 10 years, so that is the first or important thing a customer should look forward. But these things are very very new in our country. So there can be some company has a partnership with some of the maybe European company or anybody else means around the globe, US, Europe, or China, Japan, that they have executed the project. So if they have a partnership with such company and projects they have executed, they can showcase their project. So that is one of the important criteria. Second thing is that understanding of requirement. This is very, very important. Whatever is the customer requirement, a developer is able to understand their requirement or their need or not, because a lot of data need to fetch in that particular aspect. It is not so easy because this solar power industry or wind power, they are fluctuating in nature, they are not reliable. But we are working, everybody want a reliable solution. We cannot compromise with the reliability of the solution. So the amount of data need to fetch, means load profile, load growth, type of load need to handle, all those things, how much amount of data a developer is taking, and how much they are analysis and analyzing those data, and what solution they are providing. So the solution which they are providing, that also need to judge that, or they should get a clear understanding that the solution will work fine or not. See, power, energy, backup hours, these are very, very simple things that everybody understands. But there are some things which on day one that customer may not understand is the degradation part. That solar have their degradation, battery have their degradation, and these two degradation is quite different from each other. The physics of chemistry behind that is maybe the same, because type of technology people are selecting, developer is selecting. So depending upon the type of technology, energy storage have their own degradation. So day one, if the solution is met, then the customer may have a load growth, or they may have some planning, because this project ideally should be executed for 25 years or 20 years, but battery system cannot last that many years. So what is their planning? How we can go ahead? Such thing is very, very important. So the solution they should look for is the solution is right now also applicable and in future also applicable. The third thing is technology adoption. The whatever developer is providing to you, see, right now people are talking more about battery technology and more about lithium ion. So okay, fine, we can work for that. But after 10 years down the line, when we have to change the system or any augmentation need to do, so what option developer have for that particular time? They have the option or not? They can be, means any technology can lead after 10 years or 5 years or 6 years, nobody knows. Right now we are working more aggressively for lithium ion, and I agree with what Manohar sir has told just now, that we are also only looking, battery is only the solution which is looking right now looking for, but there are other options also available. So after 10 years, can they provide a solution which is compatible at that particular time, cost effective at that particular time? That also a client should understand, a customer should understand. Another thing is that the management commitment, whatever developer they are looking for, the management commitment and team is also important. Because when they are signing a PPA, suppose any client want a PPA project, so this PPA is going to run for 25 years or 20 years. So it is a long-term contract. So it is, means, bonded. Both people are bonded for long term. So management commitment is there or not? That also is important. Another thing they should work is that O&M activity. What is the O&M support a developer can provide? See, we used to talk that lithium ion or any technology, they are free from, they do not require any maintenance. But that is not the case, because when you run for this such battery, such technology for 10, 20, 50 years, 15 years, so periodically O&M is required. We have to do some O&M activity, some adaptive O&M. Or another thing they should look is the data analysis. What analysis, the once the project is executed, system is running, energy is delivered. Say at that particular time, what are the data they are collecting and how they are analyzing and what they are providing the solution for O&M activity or any augmentation or whatever they are doing. So such thing, I think the developers, this client should know. Another, the last but not the least, the most important aspect is the safety. Safety norms of the developer. Safety is very, very important, very challenging for this particular, because it is, if you are working for a lithium ion technology, it is dangerous, no doubt. It is dangerous. We have in past, in history, some lot of accident happened with this technology. So safety norms is important, and the final one is the end of life solution. Because once the 10 years over, at that particular time, what this developer will do with the existing system, how they are going to dump it or scrap or whatever they will do, something should be there. Some planning should be there right now. Otherwise, it will be very difficult. At that particular time, it will create a problem that now what we can do with this. So these are the some of the key aspects a client should look for this developer in selecting a developer. From system integrator point of view, if I will talk, the system integrator should first of all understand the application. What all application this solar plus storage is going to provide the customer. Application is very, very important. It can be solar power smoothing, peak shift, or any ancillary services, voltage regulation, frequency regulation, black start. Can be anything. So they should understand what are the application customer is looking for. Another thing, life of the project. What is going to be the life of the project? Again, I say that solar has already given in past record on history. It is available that solar life is around 20 to 25 years. We can get very easily. But for battery, we do not have such evidence in our country or in another. For all the technology, lead acid, it is proven technology. No problem. It has, but they have their own advantages and disadvantages. But for the new technology like lithium ion or anything, this is very difficult to say at this point of time that it is proven that it will work for 10 years with the degradation this OEM is offering. It is not so easy. And then load profile also system integrators should understand, because one is the charging and another is the discharging. That's all for the battery technology. That cannot do anything else apart from charging and discharging. But when to charge, with how much energy to charge, with how much power we should charge, and when to discharge, that is the critical thing. And if a person understand, a developer understand that, system integrator understand that, then he can create a wonder in the field of battery technology. That is my assumption. Okay. Then the next is the selection of energy storage. Say we cannot bias as a system integrator. You should not bias to any technology. That you should go only for lead acid or for lithium ion or for LFP, NMP, NMC, anything. See, depending upon the requirement, on the application, backup power requirement, you should select the technology. The technology can be lead acid, can be lithium ion, that is not a problem. But it is not that some of the places, if flow battery is more promising, at that particular place, if you provide a lithium ion, that may not be a optimum solution for any customer. Selection of technology is important. It can be pump hydro also. It is not necessary that we should go for this electrochemical cell only, like Manohar sir has told just now. Okay, pump hydro can be a promising solution depending upon the geographical nature and all those things, because it has some dependency. Then capacity of the battery. If they are going for a lead acid or any means electrochemical cell technology, then how much capacity we should provide? Because again, I have told that any technology, they have degradation, inherent degradation. If they will work, then it will degrade slowly and slowly, depending on a lot of factor is affecting the life of the battery or degradation of the battery. But battery will degrade slowly, slowly it will degrade. So capacity is equally important. How much capacity we want to offer, but at the same time, the provision of argumentation is also important. That if we will go for a higher capacity for a small project in the beginning, the capex will be high, the opex may be O&M will be high, or we can go for a argumentation that periodically after certain period of time when it reduces, that we can add some extra capacity. But again, it also depends upon the project size. Selection of EMS is very, very important. EMS being like mind for this whole system, is the heart of whole system. So EMS will decide everything. Selection of EMS, selection of PCS, and then the compatibility of EMS, PCS, BMS, battery, or is energy storage, whichever energy storage is seeking. Their competency is equally important. They should understand what is how much they are compatible. Then another thing is that while sizing, the most important thing we should understand is the degradation. Solar is also degradation in nature. Battery is also degrading in nature, but their rate of degradation is different as of today. So if ideally if they are degrading at same rate, then it would have made the life of a integrator much more easier. But that is unfortunate that this degradation is different. So considering degradation is equally important. Another thing is the grid. Our grid is the most powerful thing in whole power system. And once you are connected to grid, you have to run according to grid. You cannot run according to your own. So the grid understanding of grid is equally important. Otherwise, it can destroy a project, any grid, whenever it is connected. So power evacuation study, lifetime planning, how much we have to plan for future, that conductor cable and all those things, transformer related things. Power evacuation studies is equally important. Transient study is also important whenever there is a fluctuating at the grid side, how much it is going to affect our system, our hybrid system. That is equally important. And again, the harmonics. We should not forget the harmonics. Harmonics, it can work as a ghost anytime. So harmonics is also important. Another thing is for a system integrator is important is the safety norms. Safety is very, very important. Right now, battery energy storage system is at a very initial stage in our country, and we do not have a means we do not have a, we cannot risk that, because safety we have to all the SOP norms from battery integrated battery OEM we have to follow for battery. Last but not the least, the very important thing which I think is that analysis of data, the battery behavior. Whenever battery is connected to grid and solar power is generation is happening, then how the battery is reacting. All the data need to fetch, store, and analyze periodically. O&M activity need to perform periodically, and decision need to take. So these are the few criteria, few design aspects that a system integrator should understand, should know. So I like to listen. Any other question if you have, sir? You can add if I miss any.
Gurpreet sir, are you there with us?
Yeah, Twinkle ma'am, can you hear me?
Yes.
Yes, sir.
Great. Thank you, Amber sir, for insightful thing. I would next welcome Mr. Balwant from Edom Infra to share your thoughts on how this large integration of energy storage and hybridization is going to affect our infrastructure, how it is going to handle that, and do you feel that data modeling and other things, other important things are going to lead this? Your thoughts on that, sir.
Great. Thanks a lot, Gurpreet, for introduction as well as questions. Also, would like to thank Solar Quarter for inviting me for this particular event. It's very interesting. I was listening to earlier sessions also, very, very informative. So it's good to be here. You have posed me two questions. I will actually try to put them on their head and try to answer the second one first and then go to the first one, if that's okay with you. So the first one is about, the question is about data modeling tools and what is their role and how we should go about it and what are the results. Okay. I won't go too much into the modeling tools per se, but I would get into the results. Certainly, first of all, why battery energy storage is required? and where it is required. I think this is a very critical issue. We heard two speakers earlier, Mr. Manoharan talked about the large grid scale battery storage, while Mr. Aziz talked about the probably the consumer side, what should be the battery storage and what are the parameters that determine the design of the battery storage over there. I come from the consulting background, utility background, and I have a little different take on this particular issue. The problem of battery storage is very similar to the reactive power problem. Where do you locate it? At a generator end, at a transmission end, or at a consumer end? And it can be located at all the three places. And the most people who have worked in utility over here would agree with me that we have made a mess of it. Okay, we have got, we don't have exactly one particular mechanism to quantify reactive power requirement, at what place we should have it, how we should have it, how should we price it, and what is the best mechanism to harness it. And probably something similar that we are doing for battery storage also, or storage also. Why do we need storage? One of the things which we talked about, or the world started talking about, is a duck curve and high ramp requirement in the evening, and that's one of the reason. Second reason we started talking about is a unreliable or variable renewable power. I heard somebody using the word unreliable renewable. I would prefer to use the word variable, because it has been proven that more than 95% accuracy we are able to predict the solar generation. So if we are able to predict something with 95% accuracy, how it is unreliable? We know how to predict it. Okay, so it's variable, and we have to accept it that it's a variable. So variable renewable energy generation, that's the second area why we started talking about battery storage. But that's not all, you know, the benefits of the battery storage. We have got several values streams that are available with battery storage, and those value streams are very important. And what modeling tools do is that they essentially help us identify those value stream, quantify those value stream, and then identify what is the best solution from the economy point of view for the battery storage. We have several value stacks. One of the value stacks is essentially the energy time shifting. We have the peak period. We have got a solar energy available during the day. You can move it into the evening. Using evening, you can do the peak shaving. We can use it for the deviation settlement mechanism, penalties reduction. Important thing is that we can also use it for the capex deferral. And capex deferral is a very, very important benefit that is available of battery storage. And finally, the ancillary services. So ancillary services is essentially the ramping up capability which is required to manage the ramp rate requirement. Ancillary services is also could be the voltage management, frequency management, any of the ancillary services management. And when we do all these analysis and when we see the value stack and along with that the cost associated with it, where does the battery solution fits perfectly? And at this point of time, at least, this solution fits very well at 33 kV, 11 kV level, wherever there is a capex deferral is required. I'm talking about the today's cost point of batteries. And I'm not talking about 10 years down the line what would happen. I will come to that even on that particular issue also. So right now, if you have a battery storage, which is a megawatt hour scale battery storage, not kilowatt hour battery storage at a C&I end, not a huge battery storage that is required at a generator end, but the battery storage is viable at a 33 kV, 11 kV level, at a utility scale level, 4 megawatt hour, 10 megawatt hour battery storage, which can be used capex deferral, which can give you benefit of ancillary services, which can give you benefit of ramp rate, energy shifting. All the benefits can be given. You put it a co-located, distributed solar plus battery storage systems that are, and that's what our analysis on several assignments show, done for the large scale projects, small scale projects, as well as the mid-size distribution company related projects. The issue comes up whether how much really battery storage you need it. And there are several projects, there are several study reports that have come out with. And CEA has done one such project, one such report. In fact, IDEM is working with Lawrence Berkeley National Lab, and we have carried out a national level study as well as the 4 state level studies. And the national level study is likely to be published this month, sometime in second or third week. Some of you who are interested in that can have a look at it. How much battery storage is really required? And we don't call it a battery storage. In the sense, we can talk about a pump hydro, but we can, and also battery storage. Battery storage could be lead acid, or it could be lithium ion, whichever, or LFP, or whatever could be the chemistry. But these are battery storage technologies. We don't talk or call them as a battery storage technologies, but we call them as a flexible resources. And here the issue comes up, what do you really need? You need a battery storage, or a storage, energy storage, or a flexible resource, or you need a RTC power. Okay. In fact, RTC power, in my view, is a misnomer. You don't need RTC power. Consumer load is going to be variable, and there are so many operational philosophies available to system operator that you don't really need to look at the RTC as a scheme. But coming back to the issue of the storage, so we call it a flexible resources, and we have talked about 4 or 5 flexible resources. And one of the important flexible resources also agricultural load shifting, industrial load shifting, demand side management, or the distributed what we call it a demand side resources. Then the gas-based generation, which could be made available very fast, and then the pump storage and the battery storage. And what is the total quantum of the demand side, total quantum of the flexible resources required? You would be surprised that when we did the analysis, there is a huge quantum of agricultural load shifting available, or the potential exists in the country, close to the 60,000 megawatt of the load that can be shifted to the solar hours, so that it coincides with solar hours. It goes away when the solar goes away. So you provide the farmers with the power during the daytime. When they need it, they don't have to run to the farm in the night time and run the risk of snake bite or falling or any other wild animal attacking them. So the flexible resources is something that we talked about it. 60,000 megawatt of flexible resources are easily available. But despite that, you also still need the storage resources, and close to 55 to 65,000 megawatt or 55 to 65 gigawatt of storage resources are required in the 2030. And our analysis shows the first grid size storage resource that is required is in 25-26 and not before that, if you look at the operational policies. The state level research shows something different, but somewhat on the similar lines. So we need battery, but we need to really look for a lot of other options before we get into the expensive battery technology. When we get into the expensive battery technology, we need to look at where exactly it is viable today, it is financially viable today, and then explore those options first before going to other options. Having said that, I will now come to the first question of yours about the infrastructure. Whether we have infrastructure for hybrid and whether as well as the battery storage technologies. Barring a few locations where the transmission constraint could be existing, I think because of the GTG project or because of the several other transmission infrastructure projects, we have enough transmission infrastructure at least available. There are challenges in some parts of Rajasthan, some parts of Tamil Nadu, and there are some very specific challenges existing. But if you look at the transmission network backbone, the sufficient transmission capacity is available. In fact, as a part of this study and several other studies which we did as a part along with POSOCO, when we were discussing, what we noticed is that the total average utilization of the transmission system has come down in last 5 years. Okay, so when I say average utilization, earlier it was say 40-42%, it has come down to late 30 or high 30s, I would put it, 35, 36, 37%. That means there is a significant transmission capacity available across the country, and to be able to connect with the both renewable energy projects or battery energy storage projects. In fact, as soon as you put up hybrids, your ability to your utilization of the transmission asset goes up, because your CUF of the solar plus wind goes up from anywhere around 20-22% of solar to 45-50% of the hybrid system. So as a result, the transmission utilization goes up, and that's a good thing. If we add storage to it, probably the transmission utilization would further go up. So the transmission infrastructure per se, barring for the certain areas, I don't think there is a challenge. What is the challenge in there? The challenge is existing definitions of hybrid, the how the open access is granted. The open access should be granted based on the total hybrid capacity. In the sense, when it's the 40 megawatt of solar and 60 megawatt of wind or vice versa, you don't really need 100 megawatt of open access. You really need the transmission capacity for probably 80 megawatt or 75 megawatt. And that is not being permitted right now under the open access regulations. And that is something that needs to be done. If you do that, if you are allowed to optimize your investments in transmission by way of allowing for the open access capacity in accordance with the actual requirement, there will be better utilization of the transmission. And that's where the improvement is required. That's where the regulations need to change. What also need to change is that how exactly you are going to treat the BESS. There is still no clarity in terms of how the BESS would be treated. And that is something, which is a couple of our clients, when we discussed, they are kind of taking a very conservative view in terms of how it would be treated. How the what we saw in the rooftop side, and that's what worries many people. Like, rooftop side, one of the commissions has come out with the order saying that even if the solar rooftop system is behind a meter, without any with the reverse power relay, still it would be treated into the gross metering basis and not allowed to be used as a BTM system. So these kind of a changes in the regulation is something that is worrying and worrying the market, and probably stopping the consumers from implementing the C&I, consumers from implementing the BESS system. I would stop over here, but if anybody has questions, we'll be happy to respond.
Sure. Thank you so much, Balwant sir. It was very insightful on the infra and the burning question, of course, of a large format versus distributed. We used to have this format in the solar projects also, but again in the battery storage, this becomes a question. Talking of distribution, I would invite Mr. Vikas Arya from Jackson. And Vikas sir, in 5 quick minutes, we would love to know from you that what is the impact that the government's PLI scheme is going to have? I mean, your group has been into the power sector pretty long. You have been into manufacturing. You already have good plans of setting up solar cells plants. So you're already into the cycle of, one of the beneficiaries of PLI. And you have been very close to C&I segment. I mean, by the DG said. So in 5 quick minutes, sir, what are your thoughts on the PLI impact and how that is going to scale up the BESS in India?
Yeah, thank you, Gurpreet. Thank you, Mr. Joshi, for the insightful to this program. I think it was very knowledgeable session from your end and by other speakers. So carrying forward to Mr. Gurpreet's point, so I think PLI is going to make it is going to make a lot of changes in the way the infrastructure for battery storage is going to come. So one thing, like Mr. Balwant also mentioned, that storage is something which is the need of the hour and which is something it has to come. So if you say last 1 decade was the year of setting up of renewable, almost last 5 years, I would say it has taken exponential jump in terms of installation base in India for renewable. Now taking it to the step forward is the storage, which is going to definitely help us in maintaining the addressing many of the challenges what Mr. Joshi mentioned in his session. So all those things can be addressed by this battery storage. Now, because this is being a very capital intensive project, it is not something very easy to be for everybody. Mukesh Ambani definitely they have announced a very gigawatt factory, but not many Mr. Ambanis are there in the country today. So keeping that in mind and the overall infrastructure, I think this PLI is going to make a lot of interest for the various investors within the country and even from the global players as well to set up their manufacturing plants in India. And that is where it is going to be a game changer. Today we are totally dependent on China. Whatever imports or China or Korea or Taiwan, so all the lithium batteries we have been importing from them. But the way India is going forward with the new energy storage mission announced and the kind of gigawatt hour of storage systems we have announced, so it's a huge potential that is coming up. And next decade, I think next 10 years will be dedicated to storage. So, and this is the starting point of that. And this particular PLI, is going to boost that initial investment and also reduce the overall cost of the cell manufacturing in India with this incentive from the government. So, because setting up factory is not an issue, but making it competitive and making it viable in the economics in the total scenario of the business proposition is important. So that is where we have been, lacking in solar. Also, the PLI scheme came only this year, so it was slightly delayed in solar. But I would say in storage, at least, we are a little bit in advance as compared to the solar PLI scheme. So everybody is waiting for that final blueprint of the PLI scheme for the storage, how it comes out. And but we see, it is definitely going to have a very positive impact, and it is going to reduce the cost of storage. And the other things which we see, we are into this DG business or power solution business for last 50 years. So the challenge today, what everybody is is facing is the kind of pollution levels that are being coming up globally, whether it is from thermal power plants or from the running of DG sets or any other this petrol and diesel vehicles. So EV is also going to be have a big boost on the storage requirements. So both is renewable and EV sector. So these are the driving forces for the battery storage solution, which is going to make a huge impact on how we look at the business. I think it is only a matter of time when we start looking at the solar as well as this the storage system as very common available at the houses, at the offices, at the C&I sector customers. In fact, this year 2021 injection, we call it as year of hybrid. So we have already introduced our BESS systems. Earlier this year we already introduced our battery energy storage system. We have already supplied it to 2-3 customers of 15 kilowatt and 50 kilowatt systems, which are giving a very, very good results. So we are getting very encouraging feedback from the customers. That with this they are not able to. They are not only getting power in case of cut down of the supply. They are also able to avoid running out DG sets for the short duration of power cuts. So this best system what we have designed is primarily for 1 hour to 2 hour of backup for the customer. So which is definitely taking care of it, and we are getting a very good response from all the customers. And this energy storage is something which we are very hopeful that it will address many of the challenges that as an industry or as a consumer we are facing. Over back to you, Garbhiji. Back.
Amazing, sir. That was very, very brief and very crisp highlight of PL. And I was just about to add what you added on the electric vehicle. I guess when for one factory there are two large sectors of as off-takers of the power and transportation, I think it is a kind of a very lucrative business case for people to come it up and set up. Of course, the regulations have to be in place. Right, great. So with that, I would invite Mr. Sandeep as co-founder and director of Solar 91. Sandeep, my question to you would be: you do a lot of EPC, you set up, you are again very close to C&I segment. So what is your take on the adoption of solar plus energy storage in the C&I sector specifically, Sandeep?
Yeah, hello everyone. This is Sandeep, co-founder director at Solar India. I would like to thank Solar Portal for arranging this and giving us an opportunity to share our views in front of fellow speakers and all the viewers. I think adoption of solar rooftop has caught the pace in last few years for C&I segment, and all C&I consumers are willing to go ahead with solar, especially due to decreasing prices, which actually accelerated the adoption. Now, with prices around rupees 35 rupees per watt plus payback period between 3 to 4 years, it is really a smart move for C&I consumers to adopt solar and save on electricity prices. However, with government recently discouraging the net metering in rooftops and storage prices going down, I think storage solutions are the need of the hour. So EV segment in terms of charging station has also given a rise to Earth's storage solution. My particular views on the adoption regarding the C&I are, so there are few challenges in storage which everyone has shared recently is that at initial level is the cost of storage. Then again the technology selection. Third, I would say storage is not just about providing a solution but understanding the need of the client. As our speakers have also shared that the application needs to be understood. And third, what would be the operational like replacement and maintenance of its batteries? I would again highlight that technology selection. So earlier lead acid batteries were there. Now you have lead acid lithium ion batteries, lithium ferrophosphate. So what would be the right solution for customer is something very intriguing. Since storage is again at a very initial level, the technology is not proven. So it is something still people are not sure how to start with. This was again a scenario of solar when back in 2015 when solar was just started, rooftop was just started. People are wondering whether to go about it or not. Similar is the case today with the battery storage. In terms of C&I adoption, I would like to highlight that yes, no net metering will give a push to it, and I have seen, so there are two types of industries. I have recently seen that either with a variable power requirement or constant power requirement. In Maharashtra, if you have come across that, there is a load factor incentive for a constant power. I particularly feel that if all the state government push a load factor incentive like Maharashtra, there they will definitely there will be adoption of battery storage in C&I segment, because they need to maintain the constant power if the consumption itself is constant power like textile industries. And if there is a variable power, a lot of people without net metering are going for zero export solution, which is essentially decreasing the utilization of solar power. I would say that instead of going for zero export, if it is possible with the decreasing prices of the BESS, we can definitely go for battery storage in the coming times. So this would be a very interesting, since now net metering is not there and zero export already giving losses to the system, or you can say reducing the efficiency of the system. Battery storage can be an alternate, a very good alternate for it. And last, I would say that yes, the prices, India is a price sensitive market. Definitely, price is going to be a concern. So any price that would be around 40 rupees, 40 to 45 rupees per watt with the battery integration would be the right point to start for adoption in CNI segment.
Right. Sandeep, how important do you think is financing of these systems in the residential sector? I also see someone asking that why residential is always left apart. We started from the large format IPP and then we came to C&I, but let's address the residential also. Do you think financing is driving? Because in solar, it has just started. I know 2 years back, that financing of the solar or the solar installers coming along with the financing options was not existing, but it has just started. Do you think what kind of sensitization is required for the lenders to understand small package storage for the residential market too?
I think if you see, I have particularly come across. So we were doing residential projects last year, and I could see multiple queries where people were looking for an EMI solutions, and a lot of solution providers provided that lending scheme. You can say had tie-ups with the banks. Why particularly? Because in the residential segment, people are not willing to pay the upfront cost, and they are the most so industries and all our business segment which are always open to risk. The people who are at house, they generally don't want to take the risk with their house, so they always want to pay the EMI because that gives a kind of a safety. And now the lenders have come up with the safety. The only problem in solar is that when banks offer the loans or anything, they ask for the security or collateral. So I think they have to consider the solar itself, especially if they're doing at home, consider it as a security rather than asking an additional collateral or anything additional. So if that norm can get softened, I think there will be a huge adoption in the solar. I think already big players like Amplus is also getting into the OPEX model and residential segment. I think there are even more players who are getting into it, and I personally know there are a lot of small HNI segment who are investing in who are offering such models in EMI uh, payment method. So it is definitely one thing that banks have to open up for the lending of the solar rooftop, that they don't need to ask for additional collateral, instead consider it as a collateral, just like cars. If you are there, if loans are available for cars, why not solar? It is in fact a fixed asset. It is not even a movable asset.
Correct. Correct. No, amazing. I think that was again very insightful. And I'm being reminded that we have very few minutes left and we have a lot of questions to answer. So, Twinkle ma'am, I think all the panelists have shared their amazing insights on the topics and very varying topics. But let's start addressing the questions that our audience has then.
Yeah, we can have one or two questions.
Sure, ma'am.
Yeah.
So, whatever residential is important, shared, encourage PV rooftops. I'm not sure if I really get that question. Can we go to the next one? I think it has to be better rephrased. I didn't got the essence of that. Sorry. Okay. Vikas, sir, would you like to take that one?
Which one?
On the screen, sir. So can we store surplus power to battery or storage system along with zero export device?
See, zero export device will work with the net metering system, and but yes, it can be without net metering zero export. Yes, it can be worked out, and but in that case, the inverter system will be different. When we are using an inverter for the battery storage, and when we are using an inverter for an with a zero export device, both are different. So zero export device means you are not doing any exports. Then you don't need on-grid inverter. When you are not using on-grid inverter, then this device is not needed. You can straight away use your inverter which is suitable for operating with the battery system. We call it a hybrid inverter or a off-grid inverters. If the net
Right.
metering is not allowed, if net metering is allowed, then you go with the hybrid solution.
Correct. So even state policies are going to play a role in this, and it becomes
Yes.
very subjective then. Cool. Now
Yes.
we can go to the next question. Hope it answers. Thank you, sir. Shankar ma'am, can you go to the next question?
Yes, I'm just looking. So just can you just see the question?
Okay, can we see innovations in fuel cells in place of lithium storage batteries? And I would like to add on top of that, I mean, and it's open to all the any of the panelists to answer that. And there are a lot of questions from the audience also around hydrogen and other things. So there are always competing technologies, right, in front. And as Balwant sir said, it is about, not about specifically this particular battery we need or that. It's about the solution and the problem we are trying to solve. So do you think what other innovations are on a high level competing with the battery energy storage system? Balwant sir, if you could take that.
Sure. I think the fuel cell technology, and if you are going to use hydrogen, we have to first look at it. What is the hydrogen production technology? If you are
Yeah.
going to use any of the fossil fuel based hydrogen production technology, it is
Yeah.
not really going to help us in our cause of implementing renewable energy. So there are, I think all of you would have heard about different colors of hydrogen. So unless and until it's a green hydrogen which is produced through electrolysis technology using renewable energy, it's not really a good idea. Today, what is the cost of the hydrogen? The cost of the hydrogen is around 300 to 350 to 400 rupees a kg for the hydrogen produced, as against the hydrogen that is available through the SMR process that is available at less than 100 rupees a kg. So the first of all, the hydrogen need to become the economically viable to be able to use it in any of the existing processes. Having said that, even if we say reduce the cost of the hydrogen significantly, in fact, today only Mr. Mukesh Ambani has announced that 111, that is the cost of 1 kg of hydrogen to less than $1 a kg in 1 decade. So that's what is 111 is. In fact, while we were our seminar or event going on, that announcement came. So till such time that happens, the hydrogen is not really going to be a very competing technology for generic applications. But for specific applications, like the transportation applications, hydrogen is going to be viable. So frankly enough, I don't see hydrogen to be a storage technology for the power system applications, especially for the diurnal storage requirement like battery storage in at least next 8 to 10 years period of time. but it can be used. The hydrogen storage, one of our studies showed that if the hydrogen storage can be used for the long-term storage, if you have got a salt caverns, if you have got a mines, or if you have got a oil rigs which are abandoned oil rigs where we can store hydrogen, we can use those areas to store hydrogen and use it say 6 months down the line, then it is viable. But for the diurnal storage requirement, electrical storage requirement, hydrogen is not going to be viable for at least 8 to 10 years period of time. Hope that answers.
Sure, sir. Amazing. So I think that would be all the questions that we would take today, but we'll be happy to address any in the personal direct messages. Just to summarize, I think there were some very interesting points which came up. What Top said is, of course, that it's a very still a very cost sensitive topic to take up, and the lenders' acceptance to that. I think even in the residential, even in the large format IPP format, the financial closures, the bankability of the technologies that we're looking at, that remains one of the concerns that is going to be there. In terms of integration, data is once again going to play a very important role, whether it is terms of monitoring, whether in terms of modeling, prediction. I think data is still going to be a important tool and an important play in the integration with the large format battery systems. And of course, you can't do all of that without the regulatory support. And we have seen that there are a couple of regulatory things that need a refresh or a kind of a better structuring, whether it is the very specific clauses between RTC tenders. We are already sitting maybe on the 7th amendment now on the RTC tender, and on the C&I segment, we know the challenges between the net metering and the gross metering going on, and all of that actually impacts how these technologies get installed on the ground and the traction that they gain. But I think on a larger note, everybody's taking a notice of that. Everybody is pretty sensitive to that, and we are very hopeful it is going to be a evolving industry. The next 5 years at least are going to be a kind of a very deciding format, both in terms of technology, regulations, how it is going to evolve. And I think thank you all the panelists for some valuable suggestions that you gave, and it was very, very insightful discussion to have. Back to you, Twinkle. That would be all from my side. Thank you so much.
Thank you very much, all of us, for the insightful session, and a special thanks to Gurpreet sir for superbly managing this session. Your industry insight and charismatic ability to engage both the audience and the speakers brought this session to life, making them informative, thought-provoking, and entertaining. So, with this positive note, we are ending today's session and promise you to come back soon with more knowledge driven virtual events. The floor is now open for networking. Thank you.
Thank you, and I congratulate Solar Quarter for such a beautiful event. Thank you so much.
Thank you.
Thank you, Mr. Gurpreet. Thank you, Twinkle.
Thank you, Gurpreet ji.
Thank you.
Yes, thank you, everybody.
Thank you, Mr.
Thank you, everyone.